Hello and welcome to CEB. Today we will design finite automata for sigma equal to 1 divisible by 2. So first of all, we will understand what is sigma equal to 1. Sigma equal to 1 indicates that this is a unary number system. So this is the unary number system. From where I came to know that this is a unary number system. Unary number system is a system which contains only one digit for creating the entire number system. So if this is a one digit that is used to create the entire number system. So what will be the possible numbers that can be generated by this single digit 1? So let us discuss that thing. So suppose we are having decimal number and now we will find out the corresponding unary number. So we are having decimal number 1. So by using single digit 1, how I will write down the unary number. So the decimal equivalent of decimal equivalent of number 1 is nothing but the number of occurrences of this digit. So decimal number 1 means 1. So how many times this 1 will be going to appear? This is going to appear only once. So this is the unary equivalent of this decimal number 1. Now we will consider decimal number 2. Decimal number 2 for this unary number system indicate this bit will be repeated twice. That means this will be number 1 and then this will be now number 2. Two occurrences of this digit indicate number 2. What is the decimal equivalent of number 3? That is nothing but the uh, repetition, 3 times repetition of this digit. So this is 1, 1 and 1. So this is number 3. The number 4. Number 4 will be 4 times this digit, that is 111. Now decimal number 5. What will be the equivalent of decimal number 5? Is nothing but 5 times this number. Now what is the equivalent of decimal number 6? Decimal number 6 is 6 times your digit. 7 will be 7 times your digit, that is 1. 8 means 8 times your digit, that is your number 1. 9 means 9 times your repetition of your bit, that is number 1. Now why we are not having number 10? Because here we have considered decimal number. Decimal number means always it will start from 0 to 9. That's why we are now going to count 10 here. Now, what we are going to do now, we are going to solve the question. What is our question is we have to find whether the unary number is divisible by 10 or not. So what we are going to do now, we are going to find out the mathematical method of solving this question. So the second step is we are going to solve by using the mathematical method. So we will solve by using the maths method. So what is there in maths method is that we have studied in our primary schools, that whenever we have to find the number is divisible by 2 or not, we are going to divide that number by 2 by using this notation. So here we are going to write divisor and here the number this which we want to divide. So 2, when number 1 is going to be divided by number 2, the remainder will be 1. So this is your remainder 1. When the number 2, for example, the second number is 2. Now we are considering the unary number system. So in unary number system, what we are going to do? We are going to write the unary representation of number 2. So this is the unary representation of number 2, which is nothing but 2 occurrences of your bit, that is 1. So this is now this 2 will be now your dividend. Your dividend is your 2 and then we are going to divide it by 2. So we can write here for our reference, we will write that this is the number 2. So now we are going to divide it. So when we are going to divide it, we will get the remainder as 0. So this is your remainder 0. Now we will consider the next number. We have considered the number, we have considered here number 1, number 2. Now we are going to consider number 3. What is number 3 in unary number system? This is number 3. So what I'm going to write here, triple occurrence of your bit, that is 1. That is your symbol. So 2. When we are going to divide 3, So this is the 3. When we are going to divide by 2, what kind of remainder we are getting? We are getting remainder 1. Now we are having the next number is 4. The 4 number is represented by the 4 occurrence of 1. So this is number 4. Now we are going to divide by 2. What we are going to get? We will get remainder as 0. Now we are having number 5. Number 5 is this one. So when we are going to divide by 2, what kind of thing we are getting? We are getting remainder as 1. Now we are having next number as 6. 1, 2, 3, 4, 5, 6. When we are going to divide by 2, what kind of thing we are getting? We are getting remainder 0. Now when we are having remainder, we are having number 7. Now if we are going to divide by 2, what we are getting? We are getting remainder 1. When we are having number, next number, what is 8. So what we are getting? We are getting remainder 0. Then we are having number, last number, which is 9. Now if we are going to divide by 2, what we are getting? We are getting remainder 1. Okay. Now we will switch to the our thesis method. So what is there in thesis method? So we are going to solve our question by using thesis method. So what is there in thesis method? What we have solved by using mathematical method, the same concept we are going to use. For using that thing, first of all, we are going to determine the number system. The number system we are using is unary number system. Unary number system means we are having only one symbol, single symbol. Okay, single symbol we are using, and that symbol is nothing but here in our case is 1. Okay, so for solving the question by thesis method, what we are going to do? We are going to consider one tape. What kind of tape it is? This is an infinite tape which is open from your right hand side, and it is going to consist of so many cells. This consists of infinite number of cells. And what we are going to do? We are going to write your bits, your symbol here. One symbol at a time will be considered here. Okay, now in order to solve this question, our question by thesis method, we will consider this tape. Plus this tape is having a pointer which is going to point you where actually you are, what is your current position. And after reading the first bit, the pointer will move to the second bit. After reading the second bit, it will point to the next bit, and so on. Okay, now this position in which we are ready for reading the data. So this position in which we are not having any input and any output, we can represent this condition, this ready condition, this ready, or we can say the start condition. We can call it a name. We can call it by a name QS. So what is QS? QS represent ready state. We are ready to accept the data. Now what kind of string is represented by QS? String represented. The string represented by QS is nothing. What kind of output generated by our QS? So output generated is nothing. Here we are not have any kind of output because this is ready to go. So now what we are going to do? Now we are going to take, as we have considered the unary number system, we have to decide how many tapes will be there. So as there is a single symbol, so the number of tape, the number of reading tape will be only 1. So based on the symbol, the number of tape will be decided by the number of symbols present in your number system. So here only one symbol is there, so we are going to use only one tape. Okay, now this is the ready position. Okay, now as this cell is your tape is consists of so many cells, we are ready to read the first symbol. So the what will be the first symbol? The first symbol will be based on your number system. The number system here is the unary number system that consists of this bit. That means I'm allowed to use only one single bit. So what is that bit? That is 1. Now this is number 1. So what is our question? Whatever number is generated. So here we are having one number, that is string is represented by taking one bit. So what kind of this string is represented? This is number 1. If this is a number 1, what is our question is You have to decide whether your numbers are divisible by 2 or not. And this thing we have already solved by using maths method. So if you are having number 1, whether the number is divided by 2. No, the number is not divided by 2. It is not completely divisible by 2. It is having the remainder 1. So what we are going to write that this is what is this kind of state is it is having remainder 1. So this state is what remainder 1 state. Let us give some name to this condition which is remainder 1. Let us call this state as Q1. Okay, and in this state what we are going to write here on the top of your tape, we are going to write the output symbols that are generated because of the operation, and here we are going to write the resultant state. Okay, so we are going to write resultant state here. So what is the state? In this state here we are going to write the current state. What is our current state? And after reading any symbol here, what kind of output is generated because of this input, and what will be the resulting state. So here in this case, when we have considered bit 1, what is the situation is this bit 1 is representing remainder 1. What was the output that was generated here after taking the number 1? The output that was generated was number 1. In the case of number 2, what was the output generated? The output was generated is 0. In the case of 3, the output was 1. In the case of 4, the output was 0. In the case of 5, the output was 1. In the case of 6, output was 0. So the output is either 0 or 1. Okay. Now here the remainder 0. This is the state which has generated output 1. So what I can write here? I will write output 1. And to this state, which is our resultant state, our current state was QS. QS after reading 1 has generated the output 1, and it is going to the next state, which is your remainder 1. That means after dividing number 1 by 2, what we are having? We are getting output 1. To this output 1, we are giving a good name which is called as remainder 1. Remainder 1 in case of your mathematical method. Now in the case of TCS method, this good name which is remainder 1 is also called or known by one more name which is called as Q1. So what is Q1? Which string is represented by Q1? This string is represented by Q1. So what is the string? The string which is represented by Q1 is 1. Okay. So which string is represented by Q1 is 1. And what kind of output is generated? Here the output is present. The output is generated is 1. Okay. Now we will go. And what here we got a new state. So as we got the new state, what we are going to do? We are going to consider that state. So this is the Q1 state, that is the resultant state. So whatever resultant state we are getting here, that we will consider as the current state. Okay. So what is our current state is now Q1. Which state, which number, which string is represented by Q1? Q1 here represent 1. So that I'm going to write here. Now this is already read string. Now here we are having next cell. After reading this bit, your pointer is now shifted here. Previously our pointer was here. After reading this bit, now the pointer is now shifted to the next cell. The next cell is empty. Now as we have used the unary number system, only one bit is allowed to be read. So what we are going to do? We are going to read the next bit. Now, after reading the next bit, your entire number, see, your entire number that is generated here is now number 2, 1, 1. So 1, after that, one more 1 is added, is making number 2. So what is the possibility of the number 2 in the mathematical method? In a mathematical method, when the number 2 is divided 2, the output was 0. So this output we are going to write here. So what is the output? Output was 0. Now, so what we are going to do? This output 0 is also known in mathematical method as a remainder 0. So what we are going to write here, we are going to write the situation as remainder 0. To this remainder 0, we are giving one name Q0. That means this situation when we are having number 2, output is generated as 0, the resultant state is now Q0. Okay, so which string is represented by Q0 is now this entire string is represented by Q0, which is 1 1. Okay. So what is the output of Q0 is 0. So that we are going to write here. Now this Q0, which was the resultant state, and this is according to our question. What was our question is whether the number is divisible by 2. And this state Q0 represent a remainder 0. That means this number, your number 2 is completely divisible by 2, and this is what we required in our question. So this is our solution. So this will be marked as the final state. So as this is the final state and this was the current state. So what is our algorithm? We have to repeat the algorithm. So this current state will be this resultant state will become now for the next processing will become the current state. So this was the previously resultant state whose current state was Q1, and now this resultant state will become the current state. So this is your next step. So what this will be considered. So in the tape, we will mark the string which is represented by Q0. What is the string? What was the string that was represented by Q0 was 1 1. So I will write this 1 1 together because this is a complete string. Okay, so now we have already read this thing string 2 already read previously in Q0, and now the pointer is going to shift to the next position. So we have shifted our pointer here. The pointer is waiting here for the next bit. What will be our next bit? As we are using unary number system, that means it will be number 1. So this number 1 will be added here at the end of your previous bit. So previous bit was your string 2. When 1 is added to previous bit 2, it will become number 3. What was the scenario with the number 3? So when we are going to add when we are going to add one more digit after number 2, which number is generated? The number generated is 3 occurrence of number 1, which is decimal number 3. So what we had considered in decimal number in your number 3. When number 3 occurrence of ones are divided by 2, it's generating the remainder 1. So what we are going to write? We are going to write remainder here, which is your remainder 1. And what is the situation? Remainder 1, we, here we are going to write that we are having the state, the condition as remainder 1. Whether we had already considered this condition, remainder 1. Yes, remainder 1 is already considered here with the name Q1. So what we are going to write? We are going to write the resultant state as Q1. Okay, so here no need of writing Q1 again, which is generating the string 111 and generating the result as 1, because this state is already considered previously. So whenever we are having any state which is generated previously, which is repeating that state again and again, that will be the end point of your solution. Now what we are going to do, we have tried to try to find out the state. Now the second step in your TCS method is to write the state transition table. So here we are going to write state transition table. So what is there in state transition table? Here we are having one rows and column method. Here we are going to write the inputs. What kind of input we have considered? We have considered the input bit 1. Here on this side, we are going to write state. So what are the state that we have considered? So we have started with the state QS. Here also, we have started with QS. So I will take that state QS first. So this is your QS. So the QS with the input 1, QS with the input QS with the input 1, what is generating? It is generating result 1. And where it is going? The QS with the input 1 goes to the resultant state Q1. So QS with the input 1, where it is going? It is going to Q1. Okay, now the resultant state is Q1. So in this diagram, in this table, now we are going to consider next state is Q1 itself. So we'll write Q1. Now we will consider Q1. Where is Q1? Q1 is here. Q1 with the next bit is 1. Where it is going? It is generating to, it is moving to Q0. So Q1 with the next bit as 1, that is going, it is going to Q0. Now this is the resultant state. Now we'll consider this one. This is Q0 and this is the final state. I will mark this by star. So Q0, now Q0 with the next bit as 1, that is going, it is going to Q1 state. So I am going to mark here. This is going to Q1 state. Okay, so this is all about the state transition diagram. The next step is we are going to, the next step in your TCS is your state transition diagram. So here I'm going to draw state transition diagram. Okay, in state transition diagram, the first thing is that I'm going to write the first state. The first state is the starting state. So I will mark within the circle. First, we have to draw a circle. Within the circle, we are going to write the state name. Now, as this is the initial state, so this has to be different from all the states. The starting state or the beginning state is always indicated by a small pointer, a small arrow that this is the initial state. So this is your initial state, I can see. Okay, now from QS on that is going, it is going to Q1. So I will draw one line, one arrow connecting. So here I will draw one circle. Within the circle, what I'm going to write? I'm going to write the resultant state, which is reachable from QS with the input 1. So this is the resultant state, which is whose name is Q1, and the QS and Q1 are connected with the help of 1. So QS on 1 goes to Q1. So I will draw a line, an arrow connecting the states. So QS on 1 goes to Q1. We have to draw an arrow in such a way that both the ends are touching the circles. Here the starting point also and this arrow mark also should touch the circles. Now from Q1, where it is going, Q1 on 1, where it is going to Q0. So the resultant state is Q0. So we'll first draw that thing. So this is your circle, and within the circle we'll write the state name, that is Q0. Plus this Q0, we already know that Q0 is the final state. So I will double circle it. So initial state is given some preference, that some importance. How the importance is shown is by putting this arrow. Another thing is that final state is also given some importance. What kind of importance is that? It is given double circle. Okay, now Q1 on 1 goes to Q0. So we'll connect an arrow from Q1 to Q0 and I will mark the, we have to write the input symbol over it. Now Q0 on 1, where it is going back to Q1. So I will draw a loop from Q0 to Q1 and we have to write input symbol here. Now this is the end of your state transition diagram because we have considered all the state QS, Q1, Q0 in your state transition diagram. Now the fourth thing that we have to do in TCS method is we have to cross-check our finite automata machine. So that is your checking, how we are going to cross check. Okay, so how we are going to cross check is that uh, we will take one input that we have not previously considered. So let us take one input, that is one string. Number four, that we have not considered while designing our machine by using the TCS method. So what is, first you have to tell us, first you have to tell yourself whether the string is acceptable or rejected according to your question. What is our question is that your number should be divisible by 2. Whether this number 4 occurrence of ones is divisible by 4. This is nothing but decimal number 4. Whether the decimal number 4 is we had already considered is divisible by 2 or not. Yes, it is divisible by 2. So what we are going to do? We are going to write yes, this is the accepted string. Okay, so this is your accepted string. That means if this is the accepted string, it should end with your final state. So which is your final state here? Your final state is Q0. That is after processing this for this string, we should end up with final state Q0. So how will cross again? So we will start, as always, we have started here with the starting state, which is QS. Here also we start with QS. Okay, and now we will read your table and find out the QS on 1, where it is going. So QS on 1. So QS on this one, where it is going to Q1. Now, what is remaining? What is remaining string after reading the first bit, the remaining string is 111. So what we are going to do now, we are going to consider the remaining string with the resultant state. The resultant state is Q1. Now I will consider this Q1 with the next bit. So next bit is 1. So Q1 on 1, where it is going? So Q1 on 1, it is going to Q0. So I will write Q0 here. So this is Q0. And what is the remaining string? The remaining string is 1, 1. Okay, now the resultant state is Q0. So what we are going to consider? We will consider only one bit here. So we'll consider Q0 on 1, where it is going. So Q0 on 1, it is going. Q0 on 1, it is going to Q1. So what we are going to write? We are going to write Q1. What is remaining here is 1, that we are going to write here. Now what is remaining? Q1 on 1. Where it is going? Q1 on 1 is going to Q0. So I will write the resultant state as Q0. So as we have ended with the, here there is not a single symbol is remaining after considering Q0, Q1 on 1, which is going to give us the resultant state as Q0. That means this is the final answer. So here we can reach your question whether the number 4 is divisible by 2 or not, is we ended with the final state, which is Q0, and we had already assumed that if we are reaching final state, that means your string is acceptable by your the string is accepted by your the string is perfectly divisible by 2, and your machine that you have generated, which is nothing but the finite automata, you have designed correctly. And if you want, you can take one more example. For example, I want to check whether the number 5 that we have not considered while designing, okay, by using the tape method, whether this is divisible, completely divisible by whether your machine is perfectly designed, we are going to consider a new string. So what is this number? Number 5 is, whether it is divisible? No, it is not divisible, leaving the remainder 1. Remainder 1 is indicated by the state Q1. So what is Q1? The Q1 is non-final state. Whenever we are reaching your output as a non-final state, that means this string is rejected by your finite automata. That means this is not the string which is divisible by 2. That means we shall not end your answer with the final state. We should end your state with any non-final state. So whenever we are going to end your string with any non-final state, That means your string is rejected by your finite automaton. So let us start. We are started. We have to start with QS. Now QS with 1, where we are going? So with QS with 1, we are reaching to Q1. So what we are going to do? We are going to write Q1. Now this is already done and this is the resultant state. The remaining strings are 1, 1, 1, 1. Now next Q1 on 1. Q1 on 1, where it is going? Q1 on 1 reaches to Q0. What is the remaining string is 1, 1, 1. Now Q0 on 1, where it is going? It is going to Q1. What is the remaining string is 1, 1. Now next one is Q1 on 1 goes to Q0. Now what is remaining one? Remaining one is 1. So now Q0 on 1, where is going? It is going to Q1, which is a non-final state. So whenever we are ended with the non-final state, that means your string is rejected by your finite automata. So this is how we have designed finite automata for unary number system divisible by 2. The next question is to design finite automata for unary number divisible by 3. So for that, we will first go by the maths method. What is that in the mathematical method is that we have to find out whether the number is divisible by 3 or not. For that, we should know the number system. As we know, the unary numbers are nothing but the occurrences of the number 1. So we had already discussed the decimal number system to unary number system conversion. So let us brief it. So whenever we are having decimal number 1, what will be the corresponding unary number? Unary number system is nothing but here we are having only one symbol for generating the entire number system. For example, I have considered bit 1. This is the symbol which can be used for generating the entire unary number system. Now, if you are having decimal number 1, what will be its corresponding unary number? The corresponding unary number is that occurrences of 1. So for number 1, how many times this symbol is going to repeat? It's going to repeat only once. For number 2 means how many times this bit is going to repeat. So this is going to repeat twice. So this is your number 2. For 3, how many times this bit, your symbol 1 is going to repeat. Symbol 1 is going to be repeated twice. For 4, how many times your symbol is going to repeat? Is going to repeat 4 times. For 5, there will be 5 occurrences of 1. For 6, there will be 6 occurrences of 1. For 7, there will be 7 occurrences of 1. For 8, there will be 8 occurrences of 1. For 9, there will be 9 occurrences of 1. And 10 number we are not considering because we had considered decimal number. Decimal numbers is having the basic units, basic symbols from 0 to 9. That's why we are not going to consider it. Now, in the mathematical method, the second method is to divide the number by your divisor. So here the first number is number 1. We have to divide by 3. So what we can find out, it is not divisible and the generating remainder 1. Second number is 2. When it is by using the unit number system, it is nothing but number 2. It is going to generate remainder 2. Second number is 3, which is the 3 occurrences of 1. It is completely divisible by 3 and generating the remainder as 0. Now the next number is 4. That is the 4 occurrences of 1, but it is divisible by 3. No, it is not divisible by 3. It is generating remainder 1. Next number is number 5, where it is divisible by 3. No, it is not divisible by 3. It is generating the remainder as 2. Now the next number is 6. Whether the 6 is divisible by 3. Yes, it is divisible by 3 with the remainder 0. The next number is 7. The 7, that is 7 occurrences of 1. Whether it is divisible by 3. No, it is not divisible by 3. It is leaving the remainder 1. Now the next number is 8. What is the output of 8 is it is leaving the remainder 2. Now the next number is number 9. What is the output? What is the remainder? Number 9 is having remainder 0. So here all the scenarios here we can find out here having the common remainders. So this situation we can pull up together. That is the number 1, number 3, number 4 and number 7 are generating what? They are generating remainder 1. Here the scenario is 2, 5 and 8. 2, 5 and 8 they are generating remainder 2. And number 3, 6 and 9 they are generating remainder 0. Now we will go for TCS method. Now what is there in TCS method? That is step 2. In TCS method, as we are having the unary number system which consists of only one symbol. So how many tapes will be there? There will be one tape. Now what is the use of this tape? This is a tape which is open from this side, from the right hand side, containing infinite number of cells. Each cell is going to read only single symbol. Here we are going to write the current state, and on reading this input, it will go to the resultant state and it is going to generate some output here. So output will write on the top. So this is how your tape will look like. As we are having only one symbol here, there will be only one tape. Now we will consider this tape which is ready for the user to input the data. So this condition will give one good name which is called as QS state. So this is your ready state, or we can say the starting state, which is given a name QS. What input is represented? What kind of input string? Input string is represented by your state, nothing. What kind of output is generated by your QS state? What kind of output? No output till now. Now what we are going to do, as we are going for the unary number system, this is your current position. We are allowed to read one symbol here. What kind of symbol? As we are having what kind of number system we are having? As we are having unary number system, we can take only one bit. What kind of bit it will be? It will be a symbol 1. We will read symbol 1. If we are having symbol 1, that means one string is generated whose name is 1. So what was the output after dividing number 1? After dividing number 1 by 3. After dividing number by 1 by 3, what we are giving, we got remainder as 1. So what we are going to write here, we are going to write remainder 1 and the remainder 1. This is your remainder 1 situation. So this situation, we can give one good name in TCS, which is called, for example, remainder Q1. So what will be the resultant state? Here we have to write down the resultant state. This is Q1. Okay. So Q1 is the state which is going to represent, which input is going to represent input 1. So this is your input string represented by Q1, and what kind of output is generated? The output generated is remainder 1, that is 1. Now this is your resultant state, and for the next processing, for the next step, this will be considered as the current state. So this is your current state with the tape. So which string is represented by Q1? We have to write here. The string that was represented by Q1 is number 1. And now this bit is already read. Now we are going to move our pointer here to read the next bit. So we are waiting here to read the next bit. The next bit, according to your number system, how many bits? Only one. There is only single bit. There is only single symbol, and that is only symbol 1. So in the next cell, we are going to write bit 1. What kind of bit is, what kind of string is generated here? The string which is generated here is your string 2. So this is your string 2. Now this string 2, what was the output of number 2? The number 2 is what? It is generating remainder 2. So we write here, it is remainder 2. So we will give one good name in TCS, for example, Q2. So what is the resultant state after reading one more bit in Q1 state? The resultant state is Q2. What was the output of Q2 is the remainder 2. So I will write remainder 2 here. Now we will consider this Q2 as a resultant state. Now Q2 is marked as a resultant string. Now which kind of string is represented by Q2? Q2 is representing string 2. We will combine them as one string. So this is two occurrence of ones, that is another string 2. Now your pointer will point to the next position waiting for the next bit. So the next bit is 1. So this is triple occurrence of 1. Triple occurrences of 1 is nothing but your number 3. So whenever we are having number 3, we are generating remainder 0. So we'll write here remainder 0. So remainder 0, we will give one name in TCS method that is called as Q0. So which string is now represented by Q0 is this string, that is triple occurrences of 1. Triple occurrences of 1. What kind of output generated is 0, and what is the resident state is Q0. Now this is your resident state, which is according to your question. What was the question? Is that we have to check whether the unary number is divisible by 3, and when the number will be divisible by 3 whenever we are having remainder 0. So Q0 is the state which is producing remainder 0. So we'll mark this as the final state. Okay, now this Q0, which is now final state, will be considered as a current state, Q0 with the next bit. So which kind of string was generated here? The number 3 was generated by Q0. So now this Q0 will be taken together and is waiting for the next bit. The next bit is 1. So Q0, which is 3, when taken with the next bit with 1, will generate number 4. So what was the scenario with the number 4? Number 4 is nothing but you are having output as 1, remainder 1. Whether the condition is already considered here, here this condition is already considered here, and we have given some name as Q1 also. So we write that thing here because Q1 is the state which has generated remainder 1. So this state is already considered. So whenever we are having the string, the state name which is going to repeat here, like state Q1 is repeated here. So that is the end point of designing your tape method. Okay, so what we are going to do now, we are going to, that is the second step of your TCS method. So this is, or you can say, the step A of the TCS method. What is the step B of the TCS method? Is that we are going to design state transition table. So we'll write state transition table here. So how we are going to write here? We are going to write input symbol. So what is that input symbol that we consider? That is number 1. And here we are going to write the states. So the state, the first state that we have considered is state QS. So we will write that first. So we write state QS here. Now QS on input 1, where it is going. So QS on input 1, QS on input 1 goes to Q1 state. So QS on input 1 goes to Q1 state. Now next, so this will now become the resultant state we have to write here. So now we are having Q1, the Q1 on 1, where it is going, Q1 on 1. So Q1 on this one generating the resultant state Q2. So we'll write here Q2. Okay, now Q2 will become the resultant state that we have to write here. So Q2 then on 1. So Q2 on 1, where it is going, Q2 on 1 is going to Q0, and which is the final state also. So Q2 on 1 goes to Q0, which is our final state. So this will now become Q0, and here we have to mark the indication of your final state, that is the star. You have to put star in front of your Q0, which is the final state. Now Q0 on 1, where it is going, Q0 on 1, it is going to Q1. So Q0 on 1 is going to Q1. So we have considered all the states which are present in your tape method. Now we will go for the third step of your TCS method, that is designing the state transition diagram. So we'll start with we will represent your state by circle, and the first state that we are going to consider is QS. As QS is your starting state, we will mark that state by putting an arrow. Now QS on 1, where it is going? QS on 1 goes to Q1. So which is the resultant state that we have to draw by putting a circle? Name that circle as Q1, and we have to draw an arrow from QS to Q1. So from QS to Q1, we have to draw an arrow and we have to write symbol on it. Okay. Now from Q1, where it is going? From Q1, it is going to Q2. So Q1 on 1 is going to Q2. So Q1 on 1 goes to Q2. So resultant state is Q2 that we have to draw by putting the circle and name it as Q2. And we have to connect them Q1 to Q2. We have to connect by the symbol 1. Now Q2 on 1. So Q2 on 1, where it is going? It is going to Q0. So Q2 on 1 goes to Q0. And what is Q0 here? We had marked that it is a final state. A final state has to be marked with the help of double circle. Now Q0 on 1, that is going, it is going to Q1. So I will connect Q0 and Q1 with 1. So this is how the diagram is completed. Now the next step of TCS method is cross-checking whether the FA is correct or not. So let us take one string which we have not considered while designing your tape method. So while designing your tape method, we have considered till 4. So now we will take a number, for example, number 5. So number 5 is represented by the 5 occurrences of 1. So now we will start with the QS, as this is the initial state. So let us take one bit at a time. QS on 1, where it is going? So QS on 1, it is going to Q1. So QS on 1 reaches to Q1. What is the remaining string? This is your remaining string, 4 occurrences of 1. Now we'll consider Q1 on 1. Q1 on 1 goes to Q2. What is remaining string is triple occurrences of 1. So triple occurrences of 1. Now we'll take one bit, one symbol, and Q2 on 1 goes to Q0. What is remaining is double occurrences of 1. Now Q0 on 1, Q0 on 1, where it is going? Q0 on 1, Q0 on 1 goes to Q1. And what is remaining here is bit number 1. Okay, now Q1 on 1, Q1 on 1 from the table. So Q1 on 1 goes to Q2. So we have reached to Q2. That means whenever you are going to reach your result endpoint as a non-final state. So non-final state represent your string is rejected. Okay, what is this Q2? Q2 represents remainder 2. So here we are having Q2 represent remainder 2. So this is your string is rejected by your FA. Now let us take one more string for number 6. We'll start with QS. Now QS with 1. QS with 1, that is going QS with 1 reaches to Q1. Okay, from the diagram. So QS on 1, QS on 1 goes to Q1. So now remaining string is 5 occurrences of 1. Now Q1 on 1, Q1 on 1 goes to Q2. So Q1 on 1 reaches to Q2. What is the remaining string is 4 occurrences of 1. Now Q2 on 1. So where it is going? Q2 on 1. Q2 on 1 goes to Q0. So we'll write Q0 here. Okay, what is the remaining string is 3 occurrences of 1. Now the next is we are going to consider Q0 with 1. Q0 with 1, where it is going? It is going to Q1 state. So we got Q1 state. Now Now we are having remaining 2 bits. Now Q1 on 1. Q1 on 1 is goes to Q2, and then Q2 on 1 reaches to Q0, which is our final state. So whenever we are ending our solution with the final state, that means your string is accepted by your DFA. Now if you are going to consider the 6 occurrences of 1 is nothing but decimal number 6. What was the case with the decimal number 6 is it was completely divisible by uh, 3. That means this has to be accepted by your finite automata, which we already got. So this is how we have designed finite automata for unary number divisible by 3. We had already solved 2 questions for finite automata divisible by 2 and 3 for unary number system. So here we are having one practice question that you have to solve by yourself. That is, you have to design finite automata for unary numbers divisible by 4. Now today's question is, we are going to design finite automata for binary number system divisible by 2. Now as this is a binary number system, it will always contain 2 bits, 2 their symbols, that is 0 and 1. So we will go and solve it first by mathematical method. So what is that in mathematical method is that we have to first find out the binary number system. So for that we would write the decimal number system, and from decimal number to binary number conversion, how it actually looks like. So we are having decimal number, we will start with 0. 0 is represented by the symbol 0. Now, this 0 can also be represented by 2 zeros, it can be also be represented by 3 zeros, and so on. Then we are having decimal number 1. For decimal number 1, from the binary bits, that is 0 and 1 can be used for representing number 1. It can be written as a single bit 1, or we can write as 0 1, or we can also write 0 0 1, and so on. The next number comes is number 2. For the conversion from number 2 into binary number system, we are having number 10, or it can be written as 0 10, or 00 10, or 000 and 10. But these 2 bits will be same everywhere. We can write number of zeros in the beginning, but we cannot add anything at the end. Now we are having number 3. Number 3 can be represented as 13, or it can be written as 0 11, or 00 11, or 000 11, and so on. Then the number 4. Number 4 is represented by 100, or 0100, or 0010, and so on. Number 5. Number 5 will be 101. Number 6 will be 110. Number 7 will be 111. Number 8 will be 1000. Number 9 is number 9 is 1001. Now the second step in mathematical way is how to divide the number by 2. So we will start with number 0. So number 0, when it is divisible, when it is divided by number 2, remainder will be 0. Now we are having number 1 in binary number system. When it is divided, we are having remainder 1. Now it can be single 0, it can be double 0, it can be triple 0, all are divisible by 2. Number 1 can be written as 1 or 01, or 0 0 1, and so on. Now we are having number 2. Number 2 is 1 1. So number 2, when it is divided by 2, we are having remainder as 0. Then we are having number 3. Number 3, when it is divided by 2, is producing remainder 1. Then we are having number 4. Number 4 is 100. This is number 2. When it is divided by 2, we are having remainder as 0. Now we are having number 5. When number 5 is divided by 2, we are getting remainder as 1. When we are having number 6, it is completely divisible by 2. Then we are having number 7. Number 7, when we are going to divide it by 2, we are getting remainder 1. Then we are having number 8. When we are going to divide it by 2, we are getting remainder 0. Then we are having number 9. When we are going to divide it, we are going to get remainder as 1. So this is your mathematical method. Now we'll go for TCS method. So the second step is we are going to solve by using the TCS method. For TCS method, what we are going to do, we have to design the solution by using the tape. So this is the tape that we are going to use. Again, I'm repeating, this is the tape which is open from the right hand side. Here we are going to write the current state. On the left hand side, at the bottom of the tape, we are going to write the resultant state. And on the top, we are going to write output. Okay, then we will go into designing. So the initial state, it is ready for reading the input is called as QS. What is the QS? Is the ready position, ready or the start state. So that is indicated by QS. Which input is represented? Which string is represented is nothing. What is the output generated? Nothing. Now, as we are having binary number system that consists of 2 bits, zeros and 1, that means there will be 2 tapes here. So based on the number system, based on the digit, we are going to have that much corresponding number of tapes. So here we are going to have 2 tapes. So here the QS will be having, we are having 2 tapes having the starting position as QS. So here we can write like that. So here we are having initial position QS. QS is the ready position and is waiting for the next bit to be ready. So the next bit, for example, as it is the binary number system can be 0 or 1. So the next bit can be 0. So let us take as 0. So the first bit that we have read is 0. So 0. Now this is the number 0. So what was the case with number 0? Number 0, when it is divided by 2, when it was divided by 2, we got the remainder 0. So here what we are going to write, it is generating remainder 0. So this is the scenario of remainder 0. So this remainder 0, we are giving the state name as Q0. Which string is represented by Q0 is 0, and what was the output generated is remainder 0. Now, so what is the resultant state is Q0, and this is the output. As Q0 satisfies the requirement present in your question. So what is given in the question? The number has to be divisible by 2. So this is it is going to fulfill the requirement. So this Q0 will be our final state. Okay. Now, as we have considered only one bit, now we have to consider the second bit also, which is 1. So the QS, this can also consider, we can read the string which is starting with 1. The first bit will be 1. Here we consider the string whose first bit is 0. Now this is 1. So what was the case? So now this bit is nothing but the string 1. What was the case with the string 1? In string 1, what we have generated? We have generated remainder 1. So we'll give, you write here the condition that is remainder 1. To this remainder 1, we are giving a name, for example, Q1. So what was the output generated by Q1 is remainder 1. Okay, and what is the resultant state is your Q1 state. So what is the Q1? Q1 represents string 1, and what kind of remainder generated, that is 1. Now what we are going to do, we are going to consider this as the current state. So we'll consider Q0 first. We have to consider Q0 also and Q1 because these two are the resultant state, and that has to be considered as the current state. So the Q0 with the current state, so how many tapes will be there? There should be, as there are two input symbols, that is zeros and one. Again, we are going to consider two tapes. And what was the string represented by Q0 is 0. So we will write here. So the Q0 is representing string 0, and now we are waiting for the next bit. So the next bit, as we are having two bits, either 0 and 1, so the next bit can be the next bit. This is your next bit can be 0 and the next bit can be 1. Okay. So when the with the current bit 0, the next bit is added, what kind of string is generated? The string generated is double zero. What was the case with double zero? With the double zero also we are getting remainder 0. So this is your output is generating remainder 0. Which state represent remainder 0? Remainder 0 state is represented by the state Q0. So we will write the resultant state as Q0. So what we are having Q0 on 0 goes to Q0. Now the next bit Q0 with the next bit has 1. The resultant next bit 1 will has created a new string 01. What was the case with 01? So the 01 is nothing but 1, and the 1 is generating the remainder 1. So what will be the remainder here? The remainder will be 1, and what is the state representing remainder 1 is Q1. So we'll write Q1 here. So we had considered Q0 with the next bit 0 and 1, but we had not considered Q1. So we will now consider Q1 state. So now we will consider Q1 state as a resultant state, and as we are having two bits 0 and 1, we are going to have two tape. So here we will consider one tape with Q1 and again one more tape with the Q1. So what was the string that was represented by Q1? Q1 represent string 1. So we will write here. This is 1 and this is again 1. And what we are doing, this is the string. This string is already considered. Now we are waiting for the next bit here. So here we will consider the next bit. The next bit, as we are having binary number system, the next bit can be either 0 and 1. So we will take first 0 here and then we will take 1 here. So if we are going to combine the current bit 0 with the previous bit 1, it will make the number 10. What is number 10? The number 10 is nothing but your number 2. So this is the number 2. What was the output of number 2? Number 2 generate the remainder 0. So it is going to generate remainder 0. And whether we had considered any state who has generated the remainder 0. We had already considered the state whose remainder is 0. That is nothing but the Q0. So no need of generating new state name. Here I can repeat Q0 state because the remainder is same. So this state is nothing but, although it is representing string 10, but the output is same 0. That's why I'm having Q0 state here. Now so what we can write? We can write here the Q0 is not only representing string 0, double 0, but it's also representing string 10. Okay, now we are having this thing. Previous string Q1 is representing 1 with the next bit as 1 will create a new string as 11. What was the case with the string 11? String 11 is nothing but the number 3. Number 3 when divided by 2 generates the remainder 1. Okay, so whether the condition is already considered here, we have already considered this condition where we are having remainder 1, which is was indicated by the state Q1. So no need of generating or creating new state name. So here I can write resultant state as Q1 whose output is 1. So So what as the states are repeated here, Q1 on 0 is generating Q0 which is already considered, Q1 on 1 generating Q1 state that is already considered. So we will stop generating the tape method. So what we are going to do, we will go for the second step, which is nothing but generating a state transition table. So for the state transition tables, what we are going to do, we are going to draw rows and columns. As we are having two bits, that is a binary number system 0 and 1, here we will consider 0 and 1. That means here we are writing inputs. And what we are going to write here, we are going to write states. Okay. So what will the state? The first state that we are considering is your QS state. So as we are writing QS state, where the first state we will write QS state here. We will write QS state. So QS on 0. So the QS state previously nothing was there on 0. Where it is going? It is going to Q0 state. So we'll write the resultant state as Q0. Then QS with the next bit S1, where it is going? It is going to Q1. So QS on the next bit S1, where it is going? It is going to Q1. Now this Q0 will become the resultant state. So we'll write Q0 as Q0 is the final state. That is according to our requirement. So we have to put asterisk. So we'll put asterisk here. Now we have to consider Q0 on 0. So Q0 on 0, Q0 on 0, that is going, it is going to Q0 state. So Q0 on 0 goes to Q0 state. Now Q0 on 1, where it is going? Q0 on 1. So this is your current state Q0 on 1, it is reaching to Q1 state. So we will write here Q1 state. Now, what is the next state that we have to consider? We have to consider Q0, which was the resultant state. Now, the time to generate to consider the Q1 state. So now we will consider Q1 state here. We'll write Q1 state. Now Q1 on 0. So where it is going? Q1 on 0. So this is Q1 on 0. It is going to Q0. So Q1 on 0, it is going to Q0. So we'll write here Q1 on 0 goes to Q0. Then we are having Q1 on 1. Q1, this is your Q1. Q1 on 1 goes to Q1 state. So we'll write here. This goes to Q1 state. So whether we had any state which is remaining to consider. So this was the resultant state considered as the current state. This was the resultant state again considered as the current state. No state is remaining to be considered. So this will be your end of designing state transition table. Now the time to design state transition diagram. That is your part C of your TCS method. So we'll design state transition diagram. Okay, so what we are going to do, first of all, we will mark, we will note down the starting table, starting state. So what is the starting state? Is QS is your starting state. How we will mark is we are going to put in a circle, and we are going to mark initial state is already marked by putting an arrow here. Now QS on 0, where it is going? QS on 0 goes to Q0 state. So we'll write Q0 as the state and Q0 as this is the final state. I will mark it as a double circle. So what is the connectivity from QS to Q0 is by input symbol 0. Now QS on 1, that is going, it is going to Q1. So there we have to draw Q1 state. So QS on 1, that is going, it is going to Q1 state. Now next we have to consider the Q0. Q0 on 0, where it is going? Q0 on 0, it is going to Q0. So Q0 on 0, we have to write to a loop because it's going to itself. So on a loop, we have to write the input symbol 0. Then Q0 on 1 goes to Q1. Q0 on 1 goes to Q1. So we have to connect Q0 and Q1 with the input 1. Now Q1 on 0. So this is your Q1 state on 0 goes to Q0. So from Q1, we are going to draw 0. Now Q1 on 1, it is going to itself like this. So this completes our table because we have considered all the states. Now we will take one example and check whether our FA is correct or not. So we will take one example that we have not taken previously. We have stopped creation of your table tape method till number 3. So for suppose we will take number 4. So for taking number 4, we'll take 100. So 100 is number 4. So whether number 4 is divisible by 2. So number 4 is divisible by 2. So the string has to be accepted by your FA. What do you mean by accepted by FA? That it should end with Q0 string. We'll start with QS. Now we'll take QS with 1. That is going QS QS with 1 is going to Q1. So we'll write QS on 1 goes to Q1 and the remaining string is 0, 0. Now we will write Q1 on 0. Q1 on 0, Q1 on 0. Q1 on 0 goes to Q0. So we'll write Q0. And what is the remaining string? Remaining string will be 0. So we have taken Q1 on 0, resultant state is Q0 and remaining is 0. Now we will write, we will take Q0, which is the remaining string, remaining state with the next bit as 0. So where it is going, Q0 here. Q0 on bit 0 goes to Q0 state. So it is going to Q0 state, which is the final state. That means the FA that we had designed is correct. Now today's question is designing finite automata for sigma equal to 0, 1 divisible by 3. So how we are going to solve it? We are going to first find out the mathematical method. We will first solve this question by using mathematical method. So what is there in mathematical method? First of all, we should know the conversion from the decimal numbers to the corresponding binary number. So as we had already discussed, the decimal number 0 is the binary number 0, decimal number 1 is binary number 1, decimal number 2 is binary number 10, decimal number 3 is binary number 11, decimal number 4 is binary number 100, decimal number 5 is 101, decimal number 6 is 110, decimal number 7 is 111, and decimal number 8 is 100, decimal number 9 is 1001. Now second step is we have to do division. So how we are going to do division is that we'll take binary number, for example, let's take 0 and we have to check whether the number is divisible by 3 or not. So we'll divide this 0 by 3. So what will the remainder? Remainder will be 0. Now we are going to divide number 1 by 3. So the remainder will be 1. If we are going to divide number 2, that is 10 by 3. So the remainder will be 2. Now if you are going to divide binary number 3, so if you are going to divide that by 3, so your remainder will be 0. If you are going to divide number 4, that is 100 by 3, the remainder will be 1. If you are going to divide number 5, that is 101 by 3, your answer will be 2. Now if you are going to divide number 6, so the remainder will be 0. Number 7, when it is divided by 3, the remainder will be 1. And number 8, when it is divided by 3, so that will be the remainder 2. And number 9 with the remainder 0. So here we can find out the number 0, which can be represented by single digit as 0, double digit by 00, triple digit by 000. 1 by single digit, 1 by double digit can be represented as 01, the triple digits as 001, and so on. So now we will go for the TCS method. So what is that in TCS method? Now in thesis method, we are going to consider one tape in which here the tape is going to grow from the right hand side. It is having infinite number of cells where we are going to write our datum. Then this is the initial state which is called as here state. Here we are going to write the current state. At the here this position we are going to write the resultant state, and at the top we are going to write the output. So this is the ready position. So we will make it, we will note it down. Ready state or the start state is indicated by QS. Now which string is represented by this state QS? No string. What kind of output is generated? No output. Now as we are having, as we had already discussed, based on the number of input symbols present, we are going to have corresponding number of tips. So as we are having two bits here, so we are going to have two tips. So here we are having two tips, and in which condition we are considering? We are considering in the initial state, that is QS. So QS here, QS here, and here we are having cell, and the pointer which is pointing to the current cell where we are going to read our bit. So as we are having 0 and 1, so the this bit can be 0. We can read the first bit as 1 also. So whenever you're having number 0, what was the case in number 0? Number 0 was divisible by 3 with the remainder 0. So here we will write the output remainder 0 and the state which is generating output 0, that is the remainder 0, and which string is represented 0. So this is called as the remainder 0 state. So this remainder 0 state we can give name as Q0. So your resultant state is Q0. Now this state in which we are having single bit 1, single symbol 1 is nothing but number 1. So number 1 when divided by 3 is going to generate remainder 1. Okay, so what kind of string is represented? Here the string which is represented is number 1. What was the output here? The output that we consider was remainder 1. So this remainder 1 state is we can call as Q1. So here we are going to write here the resultant state Q1, and here we are going to write output as 1. Now, the resultant state that we had considered here will be considered as the current state in the next step. So that we are going to consider. So here we are going to consider Q0 state. The Q0 state represent which string? Q0 represent the string 0. So we will write 0 here. So this is Q0, and as we are having binary input, that is we are having 0 and 1, so we are going to have two tapes. So for two symbols in the number system, we are going to have corresponding two tapes. So Q0, here also Q0 with the which input, which string is represented by Q0 is 0. Now we are ready to read the next bit. The next bit we are going to read at this position. So Q0 with the next bit will be either 0, and the next bit can be either 1. So this will make which number? This will represent 0 only, because single 0 is also 0, double 0 is also a 0. So whether when what was the case when double 0 was divided by 3, we got the remainder 0. So here we are having remainder 0, so we'll write output here. Which state represent remainder 0? The state Q0 represent remainder 0, so the resultant state will be Q0. Now here we are having 0, 1. So 0, 1 is nothing but the number 1. So what was the case when 0, 1 or single 1 is divided by 3? We got remainder 1. So here we will write output as remainder 1. Whether we have marked this state, this condition remainder 1 is marked by the state Q1. So we will write resultant state as Q1 here. Okay, so these are the state with the state Q0. Now Q0 is fulfilling the requirement. What was mentioned in the question is we have to design Finite Automata for checking the divisibility by 3. And what is Q0 state? Q0 state is nothing but the state which is fulfilling the requirement. So we'll mark the Q0 as a final state. So final state will be marked by putting asterisk. So here and here to remember that this is a final state. Okay, so after marking the final state, what is the remaining state that we had to consider? So the new state that was remaining to consider is Q1 state. So now we will consider the Q1 state. So what is, which string is represented by Q1 state? The Q1 is representing the input string input string 1. So we will write Q1. So Q1 represent the string 1. So here also and here also. Now we are ready to read the next symbol. So next symbol we are going to read here. As we have it binary digits 0 and 1. So the next bit can be either 0, the next can be 1. So when we are considering next bit as 1, the next bit as 0. So the number that was generated is 1 0. 1 0 is nothing but number 2. So what was the case when number 2 is divided by 3? So when the number 2 is divided by 3, we got remainder as 2. So we got remainder as 2. Whether this state is, we had already considered this kind of situation, no. So we will write that we have generated a remainder 2 state whenever we are having the string 1 0 whose remainder is 2. So this condition we can give a good name which is called as Q2 state. So this will be known as Q2 state. Now 1 1. 1 1 indicate what? 1 1 indicate number 3. So what was the remainder? The remainder was 0. So whether we had considered this state previously, the state which is generating the representing the remainder 0, yes, we have already considered that state, that is Q0. So Q1 with the next bit as 1 goes to the resultant state Q0 and whose output is remainder 0. So we have considered the newly created state Q0 and Q1 also. Now the newly created state is Q2 that we have to consider. So now we have to consider Q2. Which string is represented by Q2? Q2 is representing the string 10. So now we will write Q2. So Q2 is representing the string 10. Q2 is representing the string 10. Now we can consider the next bit. The next bit that can be either 0, it can be either 1. Now which number is generated here? The number generated is 4. Whether we had considered the 4 previously, yes, this is 100. When it is divided by 3, the remainder is 1. Whether this remainder 1 condition is previously considered, the remainder 1 condition is given a name Q1. So that we will mark here as the resultant state. Because this is the Q1 state, the remainder will be 1. Now, so whether this state is already considered, so we had considered here, so no need of marking or writing this state again and again. Now the next one is 101. 101 represents the string, 101 represents the number 5. When number 5 divided by 3, the remainder is 2. So whether we had given this any name to this remainder 2 state, remainder 2 condition, the name given is Q2. So we'll mark here that Q2 on 1 goes to Q2 state whose remainder is 2. Whether any new state is generated here, no new state is generated here. So this is the end point of considering the state method. So now what we are going to do, now we are going to write the third, that is the third step will be in TCS method. Second step your TCS method is writing the state transition table. So how we are going to write state transition table? First of all, how many bits are there? We are having 2 bits, 0 and 1. What is the initial state here? Initial state is QS. So QS on 0, where it is going? The QS on 0, it is going to Q0 state. So QS on 0 is going to Q0 state. Now then QS on 1, where it is going? QS on 1, it is going to Q1 state. So QS on 1 is going to Q1 state. Now we have to consider this as a current state. So Q0, as Q0 is the final state, we have to put asterisk here. Now Q0 on 1, where it is going? Q0 on this one going to Q0 state. So Q0 on 0 goes to Q0 state. Where Q0 on 1, where it is going? Q0 on the next bit S1 going to Q1 state. So Q0 on 1 is going to Q1 state. Now we have to consider this state, that is Q1. So Q1 on 0. Q1 on 0 goes to Q2 state. So we'll write here Q1 on 0 goes to Q2 state, and Q1 on 1, where it is going? It is going to Q0 state. It is going to Q0 state. What is remaining? We had considered Q0, Q1, Q0, Q1 is considered, Q2 is remaining. So I have to write Q2 state. Now we have to consider Q2 state with 0. So Q2 on 0 goes to Q1 state. It is going to Q1 state, and Q2 on 0, Q2 on 1 goes to Q2 state. So Q2 on 1 goes to Q2 state. So this is going to complete your state transition table. Now next step in your TCS method is that now we have to draw state transition diagram. So we will go draw state transition diagram. So what is the method of drawing state transition diagram? Is that we have to first draw the initial state. The initial state here, the QS state. So we have to write the QS state in circle and marking the initial state by this arrow. Now QS on 0 goes to Q0, where Q0 itself is the final state. So I will mark that by a double circle. What is the connection between QS and Q0? QS on 0 is going to Q0. So I will mark on arrow 0. QS on 1 goes to Q1. So I will mark one more state that is called Q1. The connection between QS and Q1 is 1. Now Q0 on 0 goes to Q0. So Q0 on 0 going to itself. That's why we are going to create a loop. And what is the input symbol is 0. Now Q0 on 1, where it is going? Q0 on 1 goes to Q1. So we have to connect Q0 and Q1. One arrow from Q0 moving towards Q1 with the input symbol 1. Now Q1 on 0 goes to Q2. So there has to be one more state which is Q2. So this is Q2. So Q1 on 0 goes to Q2 state, and Q1 on 0, sorry, Q1 on 1 goes to Q0. So Q1 on 0, Q1 on 1 goes to Q0 state. Now Q2 on 0 goes to Q1 state. Q2 on 0 goes to Q1 state, and Q2 on 1 goes to itself. So we are going to have this kind of loop. Okay, so this is how we have completed the state transition diagram. Now I have to take one string which we had not previously taken. So we had considered till number 5. Suppose we will take number 6. Now we have to first find out whether the number 6 is divisible by 3 or not. So number 6 is divisible by 3. So your remainder, your answer should be remainder 0. So remainder 0 is indicated by the Q0 state. That means we should end your transition or the calculation with the Q0 state. So we'll start with the initial state QS. Now I will take QS with the next bit S1. QS with the next bit S1. QS with the next bit S1. Where it is going? It is going to Q1. Now we will take remaining string. Remaining string is 1 0. So now Q1 on 1. So Q1 on 1, where it is going? Q1 on 1 goes to Q0. Goes to Q0. Now what is remaining? What is remaining is, after considering Q1 on 1, what is remaining is 0. So we'll write 0 here. Now Q0 on 0. Q0 on 0, where it is going? It is going to Q0. That means our calculation is correct. So this is how we will design finite automata for binary number system divisible by 3. Now we have designed finite automata divisibility by 2 and 3 for binary number system. So what will be your practice question is, you have to design. So your practice question will be, you have to design FA for sigma equal to 0, 1 divisible by 4. So that is your practice question.
So today's question is, we have to design finite automata for sigma equal to 0, 1, 2 divisible by 2. So first of all, we should know what is sigma having the bits 0, 1, 2. So what is actually indicate? So whenever we are having sigma equal to 1, in the previous video, we had discussed whenever we are having sigma equal to 1, so as we are having only one symbol, so 1 is also called as unary. So because of that, the number that was generated, the number system that was generated, that was called as unary number system. Then we are having another one more sigma, which contain 2 bits 0 and 1. Here we are having 2 bits. So 2 bits or 2 symbols are also called as, 2 is also called as binary. So because of that, the number system that was generated was called as binary number system. Now here we are having sigma, which is having 3 bits. So which is having 3 bits. So sigma equal to 0, comma 1, comma 2. What is indicate? We are having 3 symbols, and 3 is also called as ternary. So that's why the number system is called as ternary number system. Now we'll check how we will design the number system. So for considering the number system, let us take your multiplier. The multiplier in the ternary number systems are 0, 1 and 2. And what are the multiplicand? The multiplicand in the case of ternary number system are the base of 3. So 3 will be the base, and we are going to consider the power, all the powers of 3. So 3 raised to 0, 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, and so on. Now 3 raised to 0 indicate what? So 3 raised to 0, let us write here again. 3 raised to 0, 3 raised to 1, 3 raised to 2. Let me read it. So what is the power? Which power we have to consider? We have to consider power of 3. So that is nothing but as the ternary number means 3. So we are going to write the base 3 and the powers. So 3 raised to 0, 3 raised to 1, 3 raised to 2, 3 raised to 3, and so on. And what is the corresponding number that is generated is 1, 3, 9, 27, and so on. Now, so here for generating the decimal number 0, what are the, so these are the multiplicants, and we are having multipliers in the form of bits. So what are the bits which are the multiplier? The multiplier are 0, 1 and 2. Now I want to generate number 0. So how will get number 0? I want number 0, that means I want product 0. For product 0, what is the feature of number 0? Whenever number 0 is going to multiply with any other multiplicand, then your product will be 0. Suppose your multiplicand is 1 and I'm going to multiply with this multiplier 0. So what the result I will get? I will get number 0. So this is how I will get number 0. Now I want number 1. So what will be the multiplier? Multiplicand. Multiplicand is 1, 3, 9, 27. Which is the nearest number? The nearest number is 1. So I will take this multiplicand 1. What will be the multiplier? If I want to multiply with 0, I will get number 0. I don't want number 0. I want product as 1. So if I want to multiply 1 with this multiplicand 1, what answer I will get? I will get the product as 1. So this is how I generated number 1. Now I will generate number 2. Number 2, which is the nearest number for number 2 is number 1. I will take multiplicand as 1 and I will multiply with the multiplier 2. So 1 into 2, I will get number 2. Okay, now the number 3. How I will generate number 3, which is the nearest number here? So the nearest number is this 3 directly. So what I will do, I will write 3, that is the multiplicand. What will be the multiplier? If I want to multiply with 0, I will get number 0. If I want to multiply 3 with 1, I will get answer as 1. So this is your multiplier. Okay, what about this bit 1? Do you want this bit 1? No. So what I'm going to do, I'm going to reset it. So this multiplier, so this multiplicand, for example, this is now your multiplicand 1 and I'm going to multiply. I don't want this to be used. So if I want to reset it, so I will multiply it with 0. So what I will do, I will add this 3 into 1. The product of this one will be added with the product of this one. So what will be the answer? The answer will be 3 plus 0. So what I'm going to get is your product will be 3. Now, how this will be represented in the ternary number system? What is the rule? After using the multiplicand, multiply with the multiplier, what I'm going to do, we are going to drop the multiplicand. So I will drop this multiplicand and this multiplicand. So what is remaining here? Remaining here is 1 and 0. So I will write 1, 0. So the decimal number 0 is ternary number 0, decimal number 1 is ternary number 1, decimal number 2 is ternary number 2, decimal number 3 is ternary number 1, 0. Now I want number 4. So what I'm going to do, for 4, I'm going to find out the nearest number from the base 3 answer. So what are the base 3? We are having 1, 3, 9, 27. Which is the nearest number to 4? The nearest number to 4 is 3. So what? So we will get this bit. So I will select this bit. So what I'm going to do, I will going to use this multiplicand 3. So what would be the multiplier here, because I want to use it. So when I am going to use the same number, I am going to multiply it with 1. Now we got out of 4, I got 3. So which is remaining? What is remaining is 4 may say I will got 3. So what is remaining? I want number 1. So that means number 1, whether it is directly present, it is present here. So I want to use this multiplicand. So I want to set this multiplicand. So whenever we want to set this multiplicand, we will multiply it 1 with 1. Now what we want, the addition of these two products has to be 4. So what I'm going to do, 3 into 1 is 3 and 1 into 1 is 1. Now we will add them. So your product is now 4. Now how we are going to represent that in the binary, in the ternary notation is, we are going to now drop the multiplicand, and what I got is remaining multiplier, that will be the equivalent number 4 in ternary number system. So in ternary number system, now your number 4 is represented by 1, 1. Now time to design number 5. Number 5, which is the nearest number, which in the form of base 3. The nearest number will be again number 3. So I will set this number 3. So I will use the number 3 and I'm using it. So if I'm going to use it, so I will multiply, I'm setting it, so I will multiply it with 1 in order to get the product as 3. Now which is the remaining? Out of 5, I got 3. So 5 minus 3, I want number 2. So I want to use number 2. So but directly the number 2 is not present. What is present is multiplicand 1 and the multiply either 0. If I want to multiply 1 with 0, your answer will be 0. I don't want 0. If you want to multiply 1 with 1, your answer will be 1. That I don't want. I want number 2. So the remaining multiplier is 2. So I am going to multiply multiplicand 1 with the multiplier 2, so that I will get answer as 2. So what I will do, I will use multiplicand 1 from the base 3 and will be multiplied with the multiplier 2. Now your answer of your 3 into 1, the product is 3, and 1 into 2, your product is 2. Now we want to add that, so that I will get number 5. Now how the same thing will be represented in the ternary number system is that we are going to drop the multiplicand. So here we will drop the multiplicand. So after dropping the multiplicand, what I will get? I will get the number as 1 and 2. So your answer will be 1, 2. So your decimal number 5 is now represented as 1, 2. Now the time to design number 6, sorry. Number 6, whether the numbers is directly available in the base of 3. No, we got 1 and 3 and 9. So which is the nearest? 9 is very far from number 6. The 3 is somewhat related. But how I will get? I want 6 here. So this is your multiplicand, and the multiplier are either 0, 1, 1 and 2. If I want to multiply 0 with 3, your answer will be 0. If I want to multiply 3 with 1, your answer will be 3. And if now we are going to multiply 3 with 2, your answer will be 6. So what I'm going to do, I'm going to use base 3 raised to 1, that is 3, and now I'm going to multiply with 2. What about the remaining bits? The remaining base 1, whether we want to use the base 1, no, we don't want 3 raised to 0. So I'm going to reset it by multiplying the previous number, okay, by 0. So what will be your answer? 3 into 2 is 6 plus 0. Your answer is 6. But this is how we got in decimal number. Now we want to generate the ternary number. So for ternary number, we are going to drop the multiplicand. So what is remaining is your ternary number. So what is remaining, what we got here, it will be your number 2, 0. So what we got, number 6 is represented by, number 6 is represented by 2, 0. Now how I will generate number 7? So the number 7, for generating the number 7, again we have to go and check the base 3. So 3 raised to 0 is 1, that is very far. 3 raised to 1 is 3, and then we are having 9. 9 is very larger for 7, so we'll select for 3. So for 3, I will get 7. For finding the 7, we have already calculated 6. How we got 6 is 3 into 2 is 6, and what is remaining here to obtain 7 is only number 1. So I will get number 1, which is already present here, directly given here. So I'm going to use bit 3, that is 3 raised to 1. I want to use it. So I want to use by multiplying 8 with number 2. Then plus the previous number 1, I also want to use it. I want 1 as a product. So I will multiply it with number 1. So your answer will be 6 plus 1, that is 7. So how I will generate the ternary number system is that I will drop the multiplicand here, and what is remaining is 2, 1, that we have to write together. So here we have generated number 7, which is nothing but 2, 1. So this is how we will generate the number. So what will be the number 8? The number 8 will be what? The number 8 will be 3 into 2, that is number 6. And now we want number 2. How I can generate number 2? Number 1 is already given here. And if you are going to multiply it with number 2, so I will get, that is as 2. So your answer will be what? We will drop this thing, multiplicand, and your number 8 is 22 in ternary number system. So number 8 is 22 in the ternary number system. Now we have to generate number 9. So what is the base is? We are having 1, 3, 9, 27, 81, and so on. And 9 is already given here. So what? I want 9. And how I will set this 9? By multiplying it with 1. What about this 3? 3 I want to reset. So I will mark as 0. What about this 1? I don't want to use it. I will mark as 0. So your 9 is 1, 0, 0. So number 9, decimal number 9 is converted as 1, 0, 0. Now I want to generate number 10. How I will generate number 10? Previously I have already generated number 9 by setting number 9 directly. Now I want to add 1 to 9 so that I will get number 10. So I will set it. And what about number 3? I don't want this thing, so I will mark as 0. So I will get number 101 as your number 10. So number 10 is nothing but 101. So this is how we have generated the ternary number system. Now we will go back to our question. What was the question is we had to design finite automata per sigma for ternary number system divisible by 2. Now we will go and check the divisibility method. What is the divisibility method? So in divisibility method, what we have to do? We have to check the number. So we'll take with the first number. The first number is 0. When divided by 0, your remainder will be 0. The next number is ternary number 1. Ternary number 1 is nothing but 1. When it is divided by 1, your answer will be 1. The next number in ternary number system is number 2. When it is divided by number 2, your remainder will be 0. The next number, that is the ternary number 3. So how 3 is represented in ternary number system? It is 1, 0. So we'll take with the, whether the 1, 0 is divided by 2 or not. So 1, 0 in ternary is nothing but decimal number 3. So when it is divided by 2, your remainder will be 1. Now next number, that is number 4. How it is represented in ternary number system is 1, 1. So we'll take that. So number 4 is 1, 1. So when 4 is divided by 2, your remainder will be 0. What is 5? 5 is 1, 2 in ternary number system. We will cross check here also. 5 is nothing but 1, 2. So now 1, 2, that is 5 in decimal number system, and is divided by 2. Your remainder is, that is 5. So your remainder will be 1. Now we are having number 6. So number 6 is 20. When it is divided by 2, your remainder is 0. Number 7 is ternary number system is 21. This is your number 7. When number 7 is divided by 2, your remainder will be 1. Number 8 is 22. In ternary number system, when is divided by 2, your remainder will be 0. And number 9 in ternary number system is 100. You can cross check here also. The number 9 is 100. So when it is divided by 2, what remainder we are getting? We are getting remainder as 1. And as we are discussing your previous solution, so what we are going to do here, we are having the same category. All the numbers which are generating are called the total divisible by 2. So they are having the same characteristic everywhere we are finding as remainder 0. And here everywhere we can see that the remainder is 1. So they belongs to the same category and we will call them as a situation or the condition as remainder 1. Now we will go by TCS method. So when we are solving by TCS method, what we have to do? We had to consider a tape. Now how many tapes we have to consider as we are designing the solution for ternary number system? That means we are going to have 3 tapes now. Okay, now what are the tapes? Here we are going to write the current state. Here we are going to write resultant state. And here on the top we are going to write output. Okay, and this state is open at the right hand side, and each time we are going to consider only one bit at a time. So this is your infinite tape containing infinite number of cells. Now we will consider this condition as we are having 3 tapes. So this is your initial condition, ready position having 3 tapes. Okay, so this is called as the state QS, which indicate that we are reading for reading the data. So what QS indicate? QS indicate the ready or the start state. Ready state, or it is also called the start state. Now, which kind of input string is represented? So what kind of input string is represented and what kind of output is generated here? That we are going to write. So what QS represent? QS represent the position that we are ready to accept the data. What kind of input? Whether it has accepted any input here, no input, nothing is represented by QS state. What kind of output is generated here? No output is generated here, so we'll mark nothing. Now we will ready for QS, ready to accept the next bit. Again, we are going to consider the same condition and we are writing QS. So as we are having 3 bits as your ternary number system, the first bit can be either 0, the first bit can be either 1, the first bit can be either 2. Now, if you are having first bit as 0, that means we have read a string which is nothing but string 0. What was the case with the string 0 in ternary number system? When 0 was divided by 2, the remainder was 0. So, what we are going to do? We are going to mark as the condition as the remainder 0. So, we reach a state which is called as the remainder 0. So in TCS, we will give this term as the new name called Q0. And Q0 is satisfying the condition given in the question. We are searching for the string which are divisible by 2. So as Q0 is generating the state called as remainder 0, which is nothing but total divisibility by that number, this will be called as the final state. Now, what we are going to write here? So, QS on input 0 produces remainder 0, and the new name that we are giving, the remainder 0, is nothing but your resultant state Q0. Now, QS, when we read a bit, single bit we are reading, that is we have generated a string representing ternary number 1. So, what was the case in ternary number 1? In ternary number 1, we got remainder as 1. So we will write here that we are getting remainder 1. To this remainder 1, we are giving a TCS name as Q1. So what is this case? Whenever we are having string 1, we are getting the remainder as 1 and we are going to the resultant state as Q1. Now which string? This is remaining. Q0 is representing which string? String 0. And what was the output? Output that was generated is output 0. That is the remainder 0. Q1. Q1 is representing which string? Q1 is representing this string, that is 1. And what was the output? Output is written here. Output is remainder 1. Now we are having, when QS is reading number 2 only. Number 2 is ternary number 2. What was the case with the ternary number 2? Now in the case of ternary number 2 is generating remainder 0. For remainder 0, we had already considered this condition remainder 0. So that is also indicated, by the state Q0. So we'll mark this as a Q0, which is the resultant state. And what was the output? Output is present here. So we'll write here. So Q0 state, which is representing string which are accepted by the your finite automata. Here the Q0 is, we can say, is representing 0 also, and it is representing string 2 also. Okay. Now if you are having any difficulty, is that input string 0 is different from input string 2. So what we can do, instead of giving the name as Q0, you can give the name as Q2, and we can consider this Q2 as the new state. For example, remainder 0 and with the name Q2, whose string represented is as whose string is 2 and generating the remainder 0. If you want, if you're having any confusion, otherwise I'm okay with this thing, because as the result is same, no need of generating the redundant state Q2. But if you are confused that string 2 is different from string 0, so what you can do, you can go and use new state Q2. Okay. So if you are going for that method, so you can show me the answer while you can write in comment that you had to use that method. Okay. Now what we are going to do, this was the resultant state. Now this state will be considered as the current state. So Q0 is considered as the current state. So if we are considering Q0, which string was represented by Q0 is 0. So we'll consider 0 first, then we will consider 2. Okay, so Q0. So how many tapes to be generated? 3 tapes has to be generated, because we are having 3 input symbols. So here Q0 is representing input 0. Now we are ready to read the next bit. The next bit can be 0 because of the ternary number system. It can be 1, it can be 2. So when we are having 2 bits 0 0, so this 2 bit 0 0 is nothing but the number 0. What was the case with the number 0? With the case number 0 is, it is generating the remainder 0. Which state is representing the remainder 0 condition? That is nothing but Q0. So what? So 0 with the next bit as 0 is producing the remainder 0 condition, and it is going to the next state as Q0. And what kind of output is generated is 0. And as this Q0 state, which is now resultant state, is already marked here, so no need to add one more row for writing the Q0 again, because that is already present. Now Q0 with the next bit as 1, generating the number 1. Number 1, when is divided by number 2, goes to remainders 1 condition. That is already present here. So Q0 with the current bit as 0, with the next bit as 1, generates remainder 1 and goes to the next state Q1. That is already there. Now Q0 with 2 is that number 2. When number 2 is divided by 2, that is present here, is generating the result 0. So it is going to Q0 state with the remainder 0. Now Q0 is representing 0 also and 2 also. So we consider with 0. Now we will consider with 2. So Q0 with 2. So 2. Okay. So So 2 zeros representing Q zeros representing 2 with the next bit as 0. So Q0 with 2 with the next bit as 0 is creating ternary number. Which ternary number is generated? The ternary number generated is 2 zeros, nothing but 6. So whether the 6 is divisible by 2, yes, 6 is divisible by 2, generating the remainder 0. Which state is representing remainder 0 condition? Q0 is representing the remainder 0. So what we will write here, the resultant state is Q0 with the output 0. Now Q0 with the next bit as 1. So this is Q0 with the next bit as 1, which generating the number 7. When number 7 is divided by 2, is leaving the remainder 1. Remainder 1 is represented by the state Q1 with the output 1. Now Q0 with the next bit as 2 is generating the number 8. When number 8 is divided by Q0 goes to the Q0 state because it is going to generate the remainder 0. So now number 8 is divisible by 2. So we got remainder as 0. Okay, now we will go for Q1. So what is Q1? Q1 is representing what? So Q1 is representing, here it is mentioned, string 1. So Q1 is representing string 1. And now how many tapes we have to add? We have to add 3 tapes because we are having 3 input symbols 0, 1 and 2. So now current string 1 with the next bit as 0. Which number is created? The number 3 is created. So where is our number system? So this is number 10. So number 10 is nothing but number 3. So what is the case with the number 3? Number 3 is divisible by 2. What was the remainder? Remainder was 0. Which state is representing remainder 0 is Q0 with the remainder 0. Now 1, 1. 1, 1 is number 5 remaining, leaving the remainder 1. So remainder 1 condition is represented by the state Q1. Now Q1 with the next bit, Q1 with the next bit as 2. That is number 5. Number 5 is okay, this is wrong because we are dealing with the this thing ternary number system divisible by 2. Sorry. So Q1 with 1 with the next bit as 0 is the number 3. Number 3 is not divisible by 2, leaving the remainder 1. So we are going to Q1 state. And now we are having 1, 1, which is nothing but the number 4. Number 4 is divisible by 2, leaving the remainder 0. And now we are having Q1 with the next bit as 2. That is number 5. Number 5 is not divisible by 2, leaving the remainder 1. So this is how we had designed the ternary number system divisible by 2. Now, whether any new state is generated, with that we have to consider. Previously in the initial state, that is in Q0, Q state, we are having two states, Q0 and Q1, that we have considered with all the bits, that is 0, 1, 2. Okay, so now what we are going to do, we are going to draw, the next step is we have to draw the state transition table first. After table, we are going to draw the state transition diagram. So how many bits are there? As 3 bits are there, that is 0, 1 and 2, we are going to write them. Now what was the initial state? The initial state was QS. So what was the case? QS on 0. QS on 0, where it is going? QS on 0 was going to Q0. So we'll write that thing. So QS on 0 was going to Q0. QS on 1, where it is going? QS on 1. QS on 1 is going to Q1 state. So we'll write that thing. So QS on 1 goes to Q1 state. Now QS on 2, where it is going? QS on 2 was going to Q0 state. So we'll write here QS on 2 is going to Q0. Now this will be considered as the current state. As the Q0 is, we had already marked this as a final state. So we will mark in the table also. Okay, so we'll mark this as the final state. Now we will consider Q0 with 0, 1 and 2. So Q0 with this 0, where it is going? It is going to Q0. So we'll write here Q0 with 0 goes to Q0. Now next one is Q0 with the next bit S1. So this is Q0 on next bit S1, where it is going? It is going to Q1 state. So we'll write here it is going to Q1 state. Q0 on 2, where it is going? Q0 on 2, it is going to Q0. So it is going to Q0. Now, which will be the your current state? The current state is what is present in your table as the resultant state. So we had considered Q0 first. Now we'll consider Q1 as a resultant state. So now Q1 with 0. Q1 with 0 is number 3. So it is producing remainder 1 and is going to the resultant state Q1. Now Q1 with the next bit will make number 4. Number 4 is divisible by 2, leaving to resultant state Q0. Then the next bit is Q1 with 2, that is number 5. So number 5 is not divisible by 2, giving the remainder 1. So this is how we have generated the state transition table. Now we will draw state transition diagram. So how we will draw the state transition diagram? We will start with the initial state. Initial state is your QS that we have to mark by using one arrow, and we will write QS state inside the circle. Now QS on 0 goes to Q0. So here we are having Q0 state, and how we are going to connect one arrow from QS leaving towards going towards Q0 with the input symbol is 0. Now QS on 1 that is going to Q1. So QS on 1 that is going to Q1. Now QS on 2 that is going to Q0. It is going to 2 on 2 also it is going to Q0, and Q0 is the final state. We have to double circle it. Now Q0 on 0 where it is going to itself. So there has to be one loop. Now Q0 on 1 where it is going to Q1. So on 1 is going to Q1. Now Q0 on 2 where it is going to Q0. Now Q1 on 0 where it is going to Q1. So what we are going to do, it is going on 0, it is going to Q1. Okay. Then Q1 on 1 where it is going to Q0. Now Q1 on 2 where it is going on 2 is going to Q1 only. Now we are going to test your FA for the string that we have not considered. So here we had considered the number 3, 4, 5, and here we had considered 6, 7, and 8. Now we will go for number 9. So what is number 9? Number 9 is nothing but 100. So when 100, whether the number 100, that is number 9. Number 9, whether it is divisible by 2? No, it is not divisible by 2. It will leave remainder 1, or it is going to, it will leave with the non-final state. Okay, so we should end with the non-final state. So we will go and check QS with 1. So QS with 1, where it is going? QS with 1 is going to Q1 state. So QS with 1 goes to Q1 state. Now what is remaining? The remaining strings are 0, 0. Now Q1 on 0, where it is going? So Q1 on 0 goes to Q1 state. So it is going to Q1 state. Now what is remaining? This one is remaining. So we will take this one. So this bit is remaining. So we will write here. So this is your 0. Now this Q1 with 0, where it is going? So Q1 with 0 is going to Q1 state, which is our final answer. So what is Q1 represent? Q1 is a non-final state. That means your number 9 is not divisible by 2, and that we have proved by designing the finite automata. Now we will design the same ternary number. We have to design finite automata for sigma equal to 0, 1 divisible by 3. So everything is ready here. So what is your divisibility by 3? First of all, we will write down the decimal number and the ternary number system. So what is your decimal number that we to write, and the corresponding ternary number system here. So first of all, decimal number 0 is number 0. Decimal number 1 is ternary number 1. Decimal number 2 is ternary number 2. The decimal number 3 is ternary number 10. Decimal number 4 is your ternary number 1. Decimal number 5 is ternary number 12. Decimal number 6 is 20. Decimal number 7 is 21. Decimal number 8 is 22. Decimal number 9 is 100. Decimal number 10 is 101. And so on. Okay. Now we have to go and check the divisibility. So we'll take each number and check the divisibility. So when the number 0 is divided by 3, the remainder will be 0. When the ternary number 1 divided by 3, your remainder will be 1. When number 2 divided by 3, your remainder will be 2. When number 3, which is nothing but 10, when 10 is divisible by 3, your remainder is 0. Remainder, your number 4, that is 1, when it is divided by 3, your remainder is 1. When number 5, that is 1, 2, divided by 3, we will get the remainder as 2. Okay, number 6 is 20. So when 20 divided by 3, what we are getting? Remainder as 0. Number 7, that is 21. When it is divided by 3, we are getting the remainder as 1. When we are having number 8, which is 22, divided by 3, we are getting remainder as 2. And then we are having number 9. Number 9 is 100. So when number 9 is divided by 3, your remainder is 0. So here we get three categories of remainder: 0, remainder 1, and remainder 2. Now what we will design by using the TCS method. So as we are designing the TCS method, so what we are going to do, we are going to have the initial state QS. So as we have previously stated that Q is the state in which we are not having any input, any output, and as we are considering ternary number system which are having 3 bits, that is 0, 1 and 2, so we are going to have 3 tapes. So here we are having 3 tapes with the initial state as QS. Now, so what is QS? It is the state, ready state, what kind of input is represented and what output is generated. No input and no output is generated. Now, with the next bit as the first bit can be 0, that we can read. I can read the first bit as 1. I can read the first bit as 2. So what is this state? What is this number? This is number 0. Number 0 is divisible by 3, leaving the remainder 0. So remainder 0 state I can write as Q0, and which is fulfilling our requirement. So this will be marked as the final state. So the QS, after reading the number 0, goes to the resonance state Q0, goes to the resonance state Q0 and leaving the remainder as 0. So which input string is represented by Q0? Input string 0, and what kind of output? Output is 0. Now QS with the input 1 is your ternary number 1. Number 1 is not divisible by 3, leaving the remainder 1. And for the remainder 1, I can write the state as Q1. So this is Q1 state. What kind of input string is represented by the Q1? Is input 1. And what was the output here? Output generated is 1. Now we are having input string 2. That is your ternary number 2. When it is divided by 3, leaving the remainder 2. So the remainder 2 can be given a name as Q2. So it is going to the state Q2, leaving the remainder 2. Which string is represented by Q2 state 2, and what was the output is 2. Now as we are having 3 resultant states, we are going to consider each state one by one with 0, 1 and 2. That's why we are going to have 3 different states here. So this is your Q0. Now, which string is represented by Q0 is 0. So 0, 0. So Q0 is representing 0. Now I'm waiting for the next bit. The next bit can be either 0, it can be 1, it can be 2. So when we are having 0, 0, it's nothing but your number 0. When number 0 divided by 3, leaving the remainder 0 and going to the resident state Q0. When we are having 0, 1, it's nothing but your number 1. Number 1 is not divisible by 3, leaving the remainder 1, going to the state Q1. When Q0 having the next bit as 2, so what is the case? The number 2 is generated. Number 2 is not divisible by 3, leaving the remainder 2 and going to the state Q2. So this Q0 state is considered. The next state that has to be considered is Q1. Now we will consider Q1. What is this Q1 state? The Q1 represent which input string? Q1 represent the input string 1. So Q1 state represent input string 1, and we are going to have 3 different tapes as we are having 3 inputs. So now we are having Q1 here, Q1 here. So Q1 with the next bit can be 0, next bit can be 1, next bit can be 2. So Q1 with the next bit as 0 is going to create the number 1, 0, which is the number 3. So we are going to check here number 3. When it is divided by 3, leaving the remainder 0. So it will go to the state Q0, leaving the remainder 0. 1, 1 is number 4, going to the remainder 1 state, that is Q1, and leaving the remainder 1. 1, 2 is number 5, generating the resultant state Q2 and remainder 2. So this resultant state is already we have marked here. So no need of writing again and again. Now Q1 we have considered. Now we will consider Q2 state. So which string is represented by Q2 state? That we have to find out. So here the Q2 state is representing number 2. So that we are going to write here. So this is number 2, and one more thing because we are having 3 input symbol. So there will be 3 tips. The next bit can be 0, it can be 1, it can be 2. So 2, 0 is nothing but number 6. It is divisible by 3. Going to the resultant state Q0 with the remainder 0. Q2 with the next bit as 1 is your number 7. Number 7 is generating resultant state Q1, leaving the remainder 1. Your 2 is number 8 with the remainder 2 going to the state Q2. So here whether any new state is generated, that we have to consider. No new state is generated. So we will stop generating the tape method. Now we will go and design the state transition table. So for that, what we will know, how many bits are there? We are having 3 bits, 0, 1 and 2. So there will be 3 columns, 0, 1 and 2. And here we are going to write the state. The initial state is your QS. So we will start with the QS. QS with the 0. QS with the 0, where it is going to Q0 state. So QS on 0 going to Q0 state, where QS with 1. So QS with 1, where it is going to Q1 state. So QS on 1 goes to Q1 state, where QS with the next bit S2. So QS with the next bit S2, where it is going to Q2 state. So we write Q2 state. Now Q0 will become this state we have to consider here. So Q0, as Q0 is the final state, we will mark asterisk here. Now Q0 with the next bit S1, where it is going to Q0. It is going to Q0. Okay, now Q0 with the next bit S1. So Q0 with the next bit S1, where it is going to Q1 state. It is going to Q1 state. Now Q0 with 2. 0 with 2, where it is going to Q2 state. It is going to Q2 state. Now, out of Q0, Q1 and Q2, we had considered Q0. Now the time to consider the remaining states. We will consider Q1 first. Not Q1. Q1 with the next bit as 0, where it is going? It is going to Q0. So it is going to Q0. Now Q1 with the next bit as 1 is going to Q1 state. And on to it is going to Q2 state. So we will write here. It is going to Q2. Now the next resultant state that we have to consider is Q2. Now Q2 with the next bit as 0, it is going to Q0 state. With Q1, it is going to Q1 state, and with Q2, it is going to Q2 state. Now the time to cross check your problem with the new string. So how many string we have considered? We have considered number 9. Now we'll consider number 10. So what is number 10? Number 10 is nothing but 1001. Sorry, number 10 is 101. Okay, so we'll take number this 101, and what is the remainder of number 10? Number 10 is not divisible by 3, leaving with the remainder 1. So we'll cross check it. So Q is on 1. So Q is on 1, what is going? Q is on 1 is going to Q1. So what is remaining here is 0, 1. Now Q1 with 0. So Q1 with 0 goes to Q0. So resultant state is Q0. Okay, now what is remaining? 1 is remaining. Now Q0 with 1. So Q0 with 1, where it is going? It is going to Q1 state. What is Q1 state? Is nothing but your remainder 1 state. So that means we have reached to a non-final state. So the number 10 is not divisible by 3. So this is how we have designed our finite automata for ternary number system divisible by 3. Now what will be your question? We have to design finite automata for ternary number system and you have to check the divisibility by 4. That is your question. So if you like my videos, so if you find it very interesting and knowledgeable, so do like the video, subscribe the channel and share the link so that others can also take the benefit of the lecture. So they can also find the way of solving the finite automata for ternary number system divisibility by 1, by 2, 3 and 4. Hello and welcome to Computer Engineering Byte. So today we will discuss how to design finite automata for decimal numbers divisible by 2. So for that, what we are going to do, first of all, we will know what is the method of designing decimal number system. So how we are going to design the decimal number system is that we are having the digits from 0 to 9. Decimal means 10. So how many bits will be needed for designing the decimal number system? In case of unary number system, unary means 1, so only 1 bit was needed. Binary means 2, so 2 bits were needed. So in the case of unary, let us say the bit is, for example, 1. In the case of binary number system, the bits are 0 and 1. In case of ternary number system, we were using 3 bits. So let the bits be 0, 1 and 2. And one more case, in case of binary number 2, so 2 will be not be present here, only 0 and 1. 3 will not be present here, so always the base will not be present. So now in case of decimal number system, how many bits will be there? Decimal means 10 numbers, but the base 10. But how many bits will be there? The bits will be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 only. Now the time to design, as we know these bits, they are already, we have the number system already, everyone knows what is decimal number system. Now what we are going to do, we will check the divisibility by 2. So we'll take the first number, that is 0. Whether 0 is divisible by 2, remainder is 0. What is remainder of number 1? Number 1 is producing remainder 1, that is not divisible by 2. Number 2 is yes completely divisible by 2, remainder 0. Number 3 is producing remainder 1. Number 4, what is doing? Number 4 is producing remainder 0. Number 5, what is doing? It is producing remainder 1. Number 6, number 6 is completely divisible with the remainder 0. Number 7 is having the remainder 1. Number 8 is completely divisible by 2 with the remainder 0. Number 9 is producing remainder 1. So this is how we have checked the divisibility. Now we will go for TCS method. As we had discussed in your previous solution, if we are having unary number system, so how many tapes will be there? Only one tape. If we are going for binary number system, how many symbols were there? 0 and 1. So 2 bits were there. So 2 tapes we are considering. In case of ternary number system, as there were 3 bits 0, 1 and 2, we have considered 3 tapes. So whether for the decimal number system which are having 10 bits 0 to 9, that means total 10 bits are there. So whether we are going to consider 10 tapes, no, we are not going to consider 10 tapes. Instead of considering that, what we are going to do, we are going to use some shortcut method. So what kind of shortcut method is that? We are going to club all the bits which are generating, all the numbers who are generating the remainder 0. So we are going to club them together. Otherwise, we are going to design 10 tapes. So instead of doing that thing, I can combine remainder 0 numbers together. So who are the numbers? Which are the numbers who are generating the remainder 0 are 0, 2, 4, 6 and 8. Which are the number generating the remainder 1 are 1, 3, 5, 7, 9. So they belongs to same category. So because of that, what we are going to do, we are going to consider them as a two set. So this will be the remainder 0 and remainder 1 condition. So now what we'll do, we will design the tape. So how many tapes we are considering? For example, only two tape, one for remainder 0 numbers, another for remainder 1 numbers. Okay. So remainder 0. How many numbers are there? 0, 2, 4, 6 and 8. And for remainder 1, we are having 1, 3, 5, 7 and 9. So let us take for example number 0. So here we are having, this is the initial state, ready state that we already know. This is the initial state. So this initial state we will write here. This is the ready state. What kind of inputs was represented by the initial state? Nothing. What kind of output is generated by the initial state? Nothing. This is Q state, ready state. Now we are going to consider this Q state. Okay. Now the first bit that we are taking is 0. Okay. So now first bit as 0 and the next bit can be from this set, that is a remainder 0 set, or can be from the remainder 1 set. So let us take, for example, I am taking the next bit as 0. Okay. Now this will become Q0 state. Now we will take the first bit. Now this can be either from the set 0 or either from the set 1. So what is the first bit in set 1? For example, I am considering 1. So we are considering 1. So this will be what? Number 1. Number 1 is divisible by 2. No, it is not divisible by 2, going to the remainder 1 state. So what is the remainder 1 state? Is that it is representing number 1 with the remainder 1. So this condition we can mark as Q1 state. So QS with the number 1 is generating the remainder 1 and going to the resultant state as Q1. And what we had considered with the Q0. So what was the Q0? The Q0 state. So what was the Q0 state is that we are considering. So this is your Q0 state that we had considered previously, and now Q0. So this is your number 0. So we have to write here, this is the number Q0. That is nothing but number 0 when divided by number 2. What kind of output we got? We get number 0. So what kind of input was represented is string number 0, and what was the output is remainder 0. Now we will consider this Q0 which is fulfilling the requirement. I will mark this as a final state. So we will consider this Q0 as a resultant state, and now we will going to mark that we are going to consider that as a current state. So now Q0. Now Q0 we can consider with the two states. What we are having? Two sets. We are having set remainder 0 and set remainder 1. So I can consider the next bit as 0 only. So this is 0, and the next bit from the set 1 I can consider as number 1. Okay, so again this is making the number 0. Number 0 is divisible by 2, leaving to Q0 state with the remainder 0, and the Q0 with the next bit as 1 going to state 1, leaving with the remainder 1. Now here I have considered only one element of your set remainder 0. Now suppose with the current bit as 0, that is your Q0 state only. So current bit is 0, and the next bit can be one element from your set 0. So what is there in set in your remainder 0? The next bit can be 2. So if I am taking 2 here, and okay, so 2 here, so which number is created is number 2. Number 2 is divisible by 0, leaving to state Q0 with the remainder 1. Here we have taken the next bit as 1 from the remainder 1 set. I can take the next element as 3 also. So if you are going to add number 3, which number is generated? Number 3. Number 3 is not divisible by 2, leaving the remainder 1 and going to the state Q1. So this is how, if you want, you can go and take 0, 4 also. You can go and take from after 0, you can consider 6 also. After 0, you can consider 8 also. Here also, after 0, you can consider 5. After 0, you can consider 7. You can consider 0, 9 also. Now we will go for state Q1. So what is there in state Q1? So we will consider here. So Q1 represent what? Q1 represent input 1. So I will write Q1 here. So this is input 1. Now the next bit can be either from the set remainder 0 or from the set remainder 1. So next bit, for example, is 0. So if I am taking after 1, if I am adding 0, what number is generated here? Is nothing but 1, 0. That is, this is 0 into 0 plus 1 into 10, because this is the decimal number system. So what is present at the unary is 0. So we'll multiply with 1, and what is present in your 10th place is 1. So I will multiply what is present at the 10th place is 1. 1 into 10 is 10, plus what is present at the unit place. At the unit place we got 0. We multiply 1 with 0. So I will get number that the product will be 0. So I will get number as 10. So this is your number 10. Number 10 is divisible by 2. Yes. Leaving with the remainder 0 and going to the state Q0. Now Q1 with the next bit from the set remainder 1. So the next bit, for example, I am taking 1. So if you are taking number 1, so which number is created here? So as this is the decimal number system, so this will be at the unit place. This number will be at the unit place, and this number will be at the 10th place. So multiply this this number with the 10th place, that is 10 into 1, and the number at the unit place with 1. So which kind of output is generated? 10 plus 1. So this number is number 11. So with the current bit as 1 and the next bit as 1, we got the new number as 11. With the current bit as 1, with the next number as 0, we generated number 10. Now suppose I can take for Q1 also, that is for Q1 on 1, and what will be the next bit? So Q1 with the next bit will be from the remainder 0 set. So for example, the next bit is 2. So now which number is generated here? So which number is generated here? This is at the unit place. So 2 into 1 plus this is at the 10th place, so 10 into 1, so 10 plus 2, that is number 12 is generated with the current bit as 1 and the next bit from the set remainder 1. So what is the next element? For example, I'm taking 3. So which number will be generated here is your 3 will be multiplied with 1, that is the unit place, and 1 will be multiplied with the 10, that is at the 10th place. So 10 plus 3, so number 13 is generated. So this is how we had generated the numbers by taking the two state Q0 and Q1. Now the time to design state transition table. Now for that we will start. How many bits are there? We are having two set, that is of remainder 0 set and the remainder 1 set. What are the bits? What are the elements of remainder 0? We are having 0, 2, 4, 6, 8. And now in remainder 1 set, we are having 1, 3, 5, 7 and 9. Now what we are going to do? We will start with the initial state. Initial state is your QS state. So QS state with the next bit as 0. So where we are moving, QS with the next bit as 0, where we are going to Q0 state. So we are going to Q0 state. Now QS with 1. Now QS with 1, where we are moving? We are moving to Q1 state. Now QS, after QS, these are the resultant states. So now we will consider these states as the current state. As Q0 is the final state, we will mark as with the asterisk. Now Q0 with the next bit as either 0 or 2 or 4 or 6 will make number 2, 4, 6 like that. So Q0 with the next bit as 0 going to state Q0. So Q0 with either 0, 2, 4, 6, that is going, it is going to Q0. Now Q0 with the next bit. So Q0, this is your Q0 with the next bit as either 1, 3, 5, 7. I have taken 3. If I have taken 5, so it will make number 5. If I have taken number 7, so 0, 7, that is your number 7. So they all are going to leave with the remainder 1. So Q0 with the next bit is either element of the remainder 1 is going to Q1 state. Now which is remaining? This one is remaining, so we will consider Q1 state. So Q1 state, what is Q1 is remainder 1. So here we are taking remainder 1. So the previous remainder is 1. Now if you are taking number 2 as the next bit, so which number is generated is 12. If the previous remainder is 1 and we have taken the one element, the first element from the remainder 0, that is 0. So it is making 10. If you are taking the second element from the remainder 0, it is making number 12. So the previous number is 1 with the next bit as a 0 or 2 or 4 or 6. So 1 0, 1 2, 1 4, 1 6, 1 8 is making number 10, 12, 14, 16, 18. All are divisible by 2. So Q1 on 0 is producing remainder 0. Okay, now Q1 with 1. What is Q1? Is nothing but the previous remainder 1. Previous remainder 1 with and the element from the set of remainder 1. What is the elements of remainder 1 is 1, 3, 5, 7, 9. So if you are combining that then as the second bit of your number. So first bit is 1, second bit is either 1 or the second bit can be 3, it can be 5, it can be 7, it can be 9. So first bit is 1 and the next bit is 3, making number 3. First bit is 1, second number is 5, that is making number 15. At the 10th place, we are having 1. At the unit place, we are having 7. So we are making number 17. At the 10th place, we are having number 1. At the unit place, we are having 9. So we are making 9. So whether the 11, 13, 15, 17 and 19 number are divisible by 2, no, they are leaving remainder 1. That's why Q1 on 1 is leaving to remainder 1. Okay, so the table is created. Now we will go and design a state transition diagram. So first we will mark the initial state, which is marked by QS state. So we are having this arrow and the name of the state, which is QS. So QS on 0, where it is going? It is going on 0, 2, 4, 6, 8, it is going to the final state, which is Q0 state. Okay, Q is on this set, remainder one set is going to Q1 state. So what are the elements is nothing but 1, 3, 5, 7, 9. So where it is going? It is going to Q1 state, which is a non-final state. Now Q0. Q0 with the next bit as 0. So at the 10 place we are having 2. At the unit place, if we are having same element, it is 2 or 4 or 6 or 8. So it is making. At the unit place, at the 10 place we are having 2. That is your current Q0. And with the unit place can be 0, 2, 4, 6 and 8 is making the number 20, 22, 24, 26 and 28. All are divisible. That's why Q0 on 0 going to Q0. So what are the elements? 2, 0, 4, 6, 8. So on this bits it is going to itself. And Q0 on 1, where it is going? It is going to non-divisible state. So from Q0 it is going to Q1 state. So on 1, 3, 5, 7 and 9, it is going to non-divisibility. Now Q1 on 0, 1, so that we had already considered. So it is going on 0, 2, 4, 6, 8, it is going to the final state. And on 1, it is going to itself. That's why we are having the self loop. So 1, 3, 5, 7 and 9. So this is how we have designed finite automata for decimal number divisible by 2. Now we will take one number which we have not considered previously and will check whether our FA is designed properly or not. Suppose we will take number 57. Number 57 is not previously considered. So we'll start with the QS state. So QS with the number 5. Where is this 5 number is present? This is an element of the remainder 1. So this is an element of remainder 1. So QS on 5. So QS on 5, where it is going? It is going to Q1. So it is going to Q1. Which number is remaining? Number 7. So we'll write here. Q1 on 7, where it is going? 7 is the element of the remainder 1. So we are having Q1 on the 7, where it is going? It is going. So Q1 on 7, it is going to Q1. So what we are going to write? We are going to write Q1. So which output is represented by Q1 is remainder 1. That means this is your non-final state. So this string is not accepted by your finite automaton. Now the second question is we have to design finite automaton for decimal number system divisible by 3. For the decimal number divisible by 3. So what we are do now we can do is that instead of designing 10 tapes, what we are going to use, we are going to design some shortcut. So how we are going to design the shortcut is that we will first go for mathematical method. We are having how many bits are present in decimal number system? We are having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the bits which are present in decimal number system. We will take one by one and determine the remainder. So when the 0 is divisible by 3, remainder will be 0. When 1 is divisible by 3, remainder is 1. When the 2 is divisible divided by 3, the remainder will be 2. When 3 is divided by 3, remainder will be 0. When 4 is divided by 3, remainder will be 1. When 5 is divided by 2, by 3, remainder will be 2. When 6 is divided by 3, your remainder will be 0. When 7 is divided by 3, your remainder will be 1. When 8 is divided by 3, your remainder is 2. When 9 is divided by 3, your remainder will be 0. Now we can combine all the elements of remainder 0 as 0, 3, 6, 9. All the elements of the remainder 1 set as 1, 4, 1, 4, 7. Okay, and all the elements of remainder 1. So what are the elements of remainder 2? Sorry, remainder 2 is 2, 5 and 8. So here we can cross check 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have considered all the 10 bits of your decimal number system. So now what we are going to do now, instead of considering 10 tapes, so we are going to have the tapes based on the number of sets that we have designed. So how many sets we have designed? We have designed 3 sets. So we will have this initial state which is called as the QS. Here we are going to write output symbol. Here we are going to write the resultant state, and here we are going to write the inputs that we are going to consider. So this is we are having the initial state which is called as the ready state QS. Which kind of input string is generated here or represented here? Nothing. What kind of output is represented here? Nothing. So now we will consider QS state. Now QS state from the remainder 0 set. So we can have what is there in remainder 0. We can consider 0 also. We can consider 3 also. We can consider 6 also. So but we will start with the 0. So the first bit can be 0. So how many tape will be there based on the set? We are having 3 tapes, and what we are going to do, we are going to consider the sets as the sets element from each set as the next bit. So this is Q0 state. So what is this Q0 state? So this is your first element of your remainder 0 set. So this is what remainder your number 0. Number 0 is divisible. Yes, it is divisible, living with the remainder 0. So what we are going to do, we will going to mark with the state name Q0 with the remainder 0. And here I can write this is the remainder 0, and that we are marking with the Q0. So which kind of input is represented here is number 0. What is the output? That is remainder 0. So that is the first thing. Now we have consider one bit from the set remainder 0. Now we will consider the first bit from the remainder 1. So here what we are going to mark, we are going to take the first bit as 1. Now, if you are going to take the first bit as 1, so this will become the number 1. So, if this is the number 1, what was the case with the number 1? Number 1 is not divisible by 3, leaving the remainder 1. So, this is, we can write remainder 1. Remainder 1, I can write as the state Q1. So, here the resultant state is Q1. Which input string is represented by the remainder 1 state is string 1, and what was the remainder is 1. Now, from this was the case for the remainder 1. Now we will consider the element from the remaining 2 or remainder 2 state. The first element is 2. So I will consider 2. So QS with the first bit as 2. So whether the 2 was divisible by 3, no, leaving the remainder 2. So we can write it down that remainder 2 is generated. Remainder 2 is generated. So we'll give the name as Q2. So which string is represented here? Number 2. What is the this thing output generated? That is remainder 2. So we'll give the name as Q2. So the remainder that was produced is 2 here. Okay. Now these are the resultant state. So we will consider here. This is Q0. Q0 represent which string? The Q0 is representing string 0. So I will consider string 0 here. Okay. Now how many sets are there? So based on that, we will create that many tapes. There are 3 sets are there. So we will consider 3 tapes here. So this is Q0. So Q0 with the next bit. The next bit will the from the set 0. So the next element from the set 0. So set 0, previously we had considered 0, now I can consider 3. So the next bit can be 3. The next bit is 3. What is making? It is making number 3. Whether number 3 is divisible by 3? Yes, leaving with the remainder 0 going to the state Q0. So Q0 the state which is according to our requirement. What was mentioned in the question is that your number has to be divisible by 3. So Q0 will be considered as the final state. Okay. Now the Q0 represent previously number 3. Now we will consider the next element from the remainder 1 set. Suppose we have already considered 1. I am taking number 4. If you want, you can consider number 1 also. But that we had already taken. I can take this. So that is your homework. You can consider number 1 again. So number, if you are going to consider number 1, again the previous bit was 0 and the next bit as 1 is creating the number 1. That we had already considered. That's why I'm moving for number 4. So if you are moving for number 4, which number is generated here? The number, sorry, from the remainder 1. From the remainder 1, the next bit is 4. So if you are having number 4, so what is the case with the number 4? It is not completely divisible by 3, leaving with the remainder 1 going to the state Q1. Okay. Now Q0 again. So what was the Q0? Q0 was representing 0 as the first bit at the unit at the 10th place. Now we are going to check what is the number present at the unit place. So we will consider the one element from the remainder 2. We have already considered number 2. I can check cross check with number 5. So we will go for the number 5. Number 5 is nothing but not divisible by 3 with the remainder 2 and going to the state Q2. Now we have considered Q0. Now we are going to consider Q1 state. What is Q1 state? From where I will get the this thing information. So here we had already marked that Q1 state is nothing but the number 1. Number 1 means remainder 1, previous remainder 1. Now, how many tapes will be there? Based on the number of sets we have created. So there will be 3 tapes. Okay, so this is Q1. That is representing number 1. Q1 representing number 1. Now we are waiting for the next bit. The next bit can be any bit from your remainder 0 set. So we have taken 3, we have taken 0. Now I can consider 6. Okay, so suppose we are having 1 6. So which number is this 1 6? This 1 6 represent number 16. That we had already not considered, but we can find out the answer. So whether this bit is now this number is divisible by 3. No, this number is not divisible by 3, leaving the remainder 1. So here, as this is leaving the remainder 1, which state will be the resultant state? Resultant state will be Q1. Now we will go and take the one element from the set remainder 1. So we have considered 1 and 4. Now we can consider number 7. So with the number 7, which number is generated? With the 7 at the unit place, 1 at the 10th place, that is number 17 is generated. So if the number 17 is generated, what will be the remainder? Remainder will be 2. Which state represent the remainder 2? Q2 state represent number 2. So it will go to the state Q2. Now the last one, Q1 with the 10 at the 10th place we are having 1. Now we are searching for the number at the unit place. So that from the remainder from the set remainder 2, we have taken 0, we have taken 5. Now I can take number 8. If I am putting number 8 at the unit place, the number that we generated is number 18. Previously, we had not considered number 18. Now we can cross check it. So if the number is 18, whether it is divisible by 2, by 3? No, it is not. Yes, it is divisible by 3. Sorry. Yes, it is divisible by 3. So it is leaving remainder 0. Remainder 0 is indicated by the Q0 state. Okay, now which state we have to consider? We have taken Q0 state, Q1 state, not the time to consider Q2 state. So we'll consider Q2 state. Q2 state represent with what input string? It is representing string 0. Sorry, string 2. So Q2 is representing 2. How many tapes will be there? As we are having 3 sets, we will consider 3 tapes. Now with the 2 at the 10th place, now here we are going to write any element from the set remainder 0. Suppose I am taking 0 here. Okay, or if you want, you can take 9. Okay, so now suppose I am taking 9. You can take 0 also, you can take 3 also, you can take 6 also, you can take 9 also. So in whatever situation, 0 you are taking 2 0, or you are taking 2 3, or you are taking 2 6, or you are taking 2 9. Always what will be the remainder? The remainder will be, so whether these all numbers are we are having this situation is we have to check whether the numbers are this thing divisible by 3 or not. So whether these numbers are divisible by 3 or not. So they are not divisible by 3. They are leaving the remainder 2. Okay, so when 20 is divided by 3, remainder will be 2. When 23 divided by 3, leaving the remainder 2. 26 का भी remainder 2 आएगा, 29 का भी remainder 2. So what is the output? The output will be 2. Which state is representing remainder 2 is Q2 state. So here we have taken one bit from the remainder 0 set. Now we will take one element from remainder 1 set. So what is there in remainder 1 set? So I can take for example 1 also. So we will write 1 at the unit place. After writing 1 at the unit place and 2 at the 20 place, at the 10th place where the number that is generated is 21. Whether 21 is divisible by 3? Yes, it is divisible by 3, leaving remainder 0. So which state represent the remainder 0? Q0 state represent the remainder 0. Now we have to consider Q2 state. We to consider Q2 state with the one element from the remainder 2 set. So for example, I'm taking number 2. So number 2 at the unit place and 2 at the 10 place, the number generated is 22. So when 22 divided by 3, leaving the remainder 1, remainder 1 state is indicated by the state Q1. Okay, so with any new state that is generated till now, we had considered all the state that was generated here Q0, Q1, Q2, that was they were the resultant state. Then again Q0, Q1, Q2 generated, then again Q0, Q1, Q2, and again we are having the sequence of Q0, Q1, Q2. So not a new, so there is no new state that is generated that we have to consider. So we'll stop generating the tape method here. So after this, what we are going to do? We are going to go for generating state transition table. Okay, so we are going to draw the state transition table, and in that, what we are going to take the inputs is will be nothing but your sets, remainder 0 set, that is 0, 3, 6, 9, and then we are having remainder 1 set, that is 1, 4, 7. Then we are having remainder 2 set, that is 2, 5, and 8. Okay. Now, what are the distinct states? We are having initial state as QS state. Now, QS on 0369. So, QS on 0369 is the initial state. Here we are consider 0, or we can consider 3, or we can consider 6, or we can consider 9. So, at that time, in any case, we are going to have the remainder 0 and we'll go to Q0 state. So, that's why we are having here we are going to write as the Q0 state. Now QS with the first element is either 1, 4 or 7. Okay, so either 1 or the first bit, either 4 or the first bit is either 7. Always is going to result in remainder 1 and they will go to Q1 state. So that's why it will go to Q1 state. Now QS, nothing is there and we are going to take any element from the set 2. What is there in the set 2? Either 2, 5 or 8. So if you are here, we have considered, I have considered number 2. So that is leaving to remainder 0, remainder 2. If you are taking number 5, so that will leave to remainder 2. If you are taking number 8, that is also leave to remainder 2. So whether we are taking any element or set to remainder 2, it will always result in remainder 2. That's why we are moving to Q2 state. Now we will consider this as a current state and Q0 the final state we will mark with the asterisk. Now Q0 with the next bit either 0, 3, 6, 9. Yes. So Q0, this Q0 and next bit as 3 is also always going to leave with the resultant state as Q0 because 3, 0, 3 or 0, 6 or 0, 9 is always divisible by 3. That's why we are having resultant state as Q0. Now Q0 with the next bit as any element from Q1 set. So it is 4 or can be 7 or can be 1. So either 4, 7 and 1 always result in remainder 1. That's why it is going to remainder 1. Okay, Q0 with the next bit as 2 or 5 or 8 always goes to remainder 2. Q. That's why we are going to the state Q2. Now next, this thing from here Q0 is considered. Now we will consider Q1. So I will write Q1 here. Q1 with the next bit as 0. For example, Q1 is previous result, remainder is 1, and the next bit is 0. This is going to make number 10. Number 10 is not divisible by 3, leaving the remainder as 1. So remainder 1 is represented by Q1. Now again Q1, previous remainder is 1 and the next bit is, for example, 4. So that is number 14. When number 14 is divisible by 3, leaving the remainder 2. That's why it is going to Q2 state. Now current remainder Q1 represent 1 with the next bit as, for example, 2. So 2 will be at the unit place and 1 will be at the 10th place, making number 12. So number 12 is completely divisible by 3. That's why we are moving to state as Q0. Now which is remaining? We have considered Q0, we have considered Q1, now we'll consider Q2. Now we'll consider Q2. Q2 represent number previous remainder 2. So previous remainder 2, that is at the 10th place. Now any element from the set remainder 0, for example 3, 6, 9, any number. For example, we will consider 0. So at the 10th place we are having 2, at the unit place we are having 0. So that is number 20. So number 20 is not divisible by 3, leaving with the remainder 2. So it will go to Q2 state. Now previous remainder, that is at the 10th place, and the next bit at the unit place, for example 1. So that is divisible by 3, going to state Q0, and the previous remainder 2 and the current bit as 2. So what will be the remainder? Remainder will be 1, so we go to Q1 state. Okay, now the time to draw the state transition diagram. So we start with the initial state, that we mark as QS with this arrow here. Now QS on 0, where it is going, it is QS on 0, 3, 6, 9 is going to Q0. So QS on 0, 3, 6, 9 going to Q0 state with itself with the final state. The final state has to be double circle. Now QS on 1, 4, 7, it is going to, on 1, 4, 7, it is going to Q1 state. That we have to mark. QS on 2, 5, 8, 2, 5, 8, is this going to Q2 state, which is also a non-final state. Now Q0 on 0, 3, 6, 9, that is going, it is going to itself. So we will mark that. So it is on 0, 3, 6, 9 going to itself. Q0 on 1, 3, 1, 4, 7, that is going on 1, 4, 7 is going to Q1. So we'll mark here that on 1, 4, 7 it is going to Q1. Now Q0 on 2, 4, 2, 5, 8, that is going, it is going to Q2. Now time for Q1. Q1 on 0 goes to itself. So Q1 on 0, 3, 6, 9 goes to itself. Now Q1 on 1, 4, 7 goes to Q2. So Q1 on 1, 4, 7, 1, 4, 7 goes to Q2. Now Q1 on 2, 5, 8 goes to Q0. So it is, we have to make this kind of connection. So on 2, 5 and 8. Okay. Now what is remaining? Q2. Where Q2 is going? Q2 on 0, 3, 6, 9 is going to itself. So we will write here 0, 3, 6, 9. It is going to itself. Okay. Now Q2 on 1, 4, 7 goes to Q0. So from here 1, 4 and 7. Okay. Now Q2 on 2, 5, 8 goes to Q1. So Q2 on 2, 5, 8 goes to Q1. Okay, so this is how we will draw the state condition diagram for decimal number divisible by 3. Now suppose we want to check the number we are not taken, for example 39. So this number we are not taken, so we'll check with the Q state. So QS on 3, where it is going? QS on 3 goes to Q0. So we will go to Q0. Which number is remaining? Number 9 is remaining. Now Q0 with 9. Okay. So Q0 with 9, where it is going? Q0 with 9 is Q0 here with 9 is going to Q0. So now this number is accepted by DFA because from the given string we are reaching to the final state. So this number 39 is divisible by 3. So this is how we are designed finite automata for the divisibility. So if you like my video, so do like it, do share it and subscribe the channel. Thank you.